डॉक्टर साहब जी।
जी सर।
हाँ, सभी कनेक्ट हो गए हैं। अक्षर जी
हाँ सर,
कनेक्ट हो गए।
बस छाया मैम हो रहे हैं, उनका कुछ इशू आ रहा है। आगे
डॉक्टर डी के चौहान कनेक्ट हो गए हैं। डॉक्टर साहब जी।
जी सर।
डॉक्टर डी के चौहान कनेक्ट हो गए हैं।
यस सर।
ओके। Daksachi? Hello?
Yes, sir.
Why late, Daksachi?
Sir, just Akshat sir is joining within 1 to 2 minutes.
Okay, okay.
ये तो सामान मंगाना है तो जाएगा। हाँ, तो वो दिखा देना ऐसे चाहिए। हाँ, चलिए आएगा। एक आध टूट जाता है, छोटे छापने में और चीज हाँ यहीं से लेके आया, यहीं से ले जाएगा। पिज्जा कहते हैं उसको, पिज्जा बिस्किट। चीनी मंगा, चाय है?
छाया मैम, छाया मैम,
जी मैम।
yeah ma'am, please start.
Okay. Good morning all of you. Am I audible to all?
Yes ma'am, yes.
ओम सरस्वती नमस्तुभ्यं वरदे कामरूपिणी विद्यारंभं करिष्यामि सिद्धिर्भवतु मे सदा. With the blessings of Ma Saraswati and on behalf of Rajkumar Goyal Institute of Technology Ghaziabad, I, Chaya Sharma, welcome you all to this 5 days faculty development program on applications of machine learning and deep learning. While entering the year 2020, we never thought that our lives are awaiting major changes. With the coronavirus pandemic taking over our lives and the nationwide lockdown restricting mobility and changing our lifestyle, online webinars, faculty development programs, and other online conversations are becoming more important. This crisis is stressful for everyone, but it does not mean to stop learning new skills. With this ideology, we, the RKGIT family, is conducting a 5 days FDP covering basics and real-time applications of machine learning as well as deep learning. On the very first day of this online faculty development program initiated by Department of Computer Science and Engineering, RKGIT. Now, I would like to invite Dr. Sachi Gupta, HOD CSE and convener of this FDP who welcome all the dignitaries, speakers, and participants. Ma'am.
Good morning, esteemed dignitaries, respected speakers, and dear participants. It's a great pleasure to welcome you all to this 5-day faculty development program on applications of machine learning and deep learning, hosted by Department of Computer Science and Engineering. First of all, please allow me to express my heartfelt appreciation to the authorities of Rajkumar Goyal Institute of Technology, Ghaziabad, for the whole support they have given in making this faculty development program reality. I would especially like to welcome all the speakers of this FDP who have kindly accepted our invitation to share their wisdom and insight during this FDP. I also would like to welcome all the participants who have made slot in their hectic work schedule and done registration for this FDP. This FDP has been designed to be practical with lectures, examples, and hands-on sessions to provide skills, encourage participation, and exchange information. I wish to tell you that we have received a great response for this program from 22 different countries like Dubai, Ethiopia, Indonesia, Iraq, Japan, Kuwait, Malaysia, Nepal, Netherlands, New Zealand, Philippines, South Arabia, Turkey, USA, and many more. Till the closing of the registrations, we have received total 2634 number of entries from all over the globe to attend this FDP. We are providing Zoom link to some participants and rest can join us through YouTube channel of RKGIT. Finally, I would like to especially congratulate the organizing committee for conducting this FDP in a fruitful manner. Looking forward to a successful program over the next 5 days, and I strongly encourage you all to become actively engaged in the various sessions, including theory and hands-on practices. Thank you all.
Thank you, ma'am. I would now request Dr. D.R. Somashekar sir, Director RKGIT, an idol of knowledge and experience, to motivate the audience of this faculty development program with his worthy words. Sir.
Thank you, Chaya. Am I audible, Chaya?
Yes, sir.
Thank you. Good morning, ladies and gentlemen. Honorable Vice Chairman of the RKGIT Group, Mr. Akshat Goyal, respected speakers of the FDP and day's speaker, Mr. Ashish Shukla, beloved Group Director, Dr. Lakshman Prasad, and Dr. D.K. Chauhan, Executive Director, the convener of the FDP, Dr. Sachi Gupta, delegates from all parts of India and outside India, and more than all, my dear students. Friends, at the outset, I congratulate the Department of Computer Science under the leadership of Dr. Sachi Gupta for organizing such a wonderful webinar on applications of machine learning and deep learning. Friends, you're all well aware we are in the COVID-19. During this period, lot of changes has been taken place in the country. It may be in the economy, it may be in a digital learning, and so on and so forth. So let me confine to the digital learning, teaching, learning process. Friends, this concept, no doubt it was an existing, but it was not familiar as it is at present. Friends, this will be the future. And the teaching, the pedagogy has taken a significant transformation. Coming to the webinar of the today, the applications of machine learning and deep learning. It is a hot burning topics of the day. No doubt, they are all the complementing each other, the artificial intelligence, the blockchain, the big data, data sciences, and so on and so forth. The deep learning is also a subset of the machine learning. In a beautiful way, the webinar has been coined, machine learning and the deep learning. say I may be too small to speak on the applications of machine learning and deep learning, but my submission to all the students, always when such webinars are organized, kindly take the advantage and be mentally and physically prepared to the such webinars even in future also. I wish all the best of luck for this 5 days FDP and wish you good luck. Thank you very much. Over
Thank you,
to
sir. I would now like to request Dr. D.K. Chauhan, sir, Executive Director, RKG Group of Institutions, to kindly motivate us all.
Thank you, Shaya. My voice is clear?
Yes, sir.
Oh, thank you so much. Honorable Vice Chairman, Sri Akshat ji. Honorable Group Director, Sri Lakshman Prasad, sir. Dr. Somsekhar, sir, Director, RKGIT, and Head of the departments. I really thank you, all of you, for giving me this opportunity. Definitely the theme of FDP is very interesting, and it's a requirement of future, as scientific discoveries and invention are moving very fast. But today's scientific advancement and achievement can impact globally in very short time. Such is the progress made in the field of machine learning. Several thrusts can be pointed out, but science and technology is trying to create a super intelligence that can outperform human beings. Not just in a specific task, but in complex intellectual activities, which includes decision-making, problems, memory, speech, recognition, attention, and judgment. In a short time and in conclusion, I just say that it's not a machine learning as a technology only. It's a part of our daily life, as we've seen in last 3 months in the pandemic duration of COVID-19. And for example, it's our personal technical and smart agent of our life, because this is recognize our all activities, what we are doing, how we talk, how we walk. So how the machine is, get our information and predict our future. For example, if we book a ticket from Delhi to Mumbai, definitely we will get a screen pop-up, and we will get a pop-up in our screen that what are the top 10 places visited in Mumbai. And definitely we will get another pop-up for the return ticket. So this is the smart agent of our life, actually. So definitely the theme is very good. And thank you so much, all of the Department of Computer Science and Dr. Suchi Gupta. Thank you. Thank you so much.
Thank you, sir. Now, I would like to request Dr. Lakshman Prasad, sir, Director R&D, RKG Group of Institutions, to shower his blessings upon all of us. Sir. Sir, kindly unmute your mic.
Am I now audible?
Yes, sir.
Our young Vice Chairman, Shri Akshat Goyal ji, Director, RKGIT, Dr. Somsekhar, Executive Director, Dr. Chauhan, eminent speakers, and my very dear participants of this FDP on machine learning and deep learning applications. I am very happy indeed to shower my countless blessings to all of you for achieving what the speakers intend to achieve and what the participants intend to gain. I am personally aware of machine learning, its applications in the field of horticulture, for sorting out apples and mangoes by size, by color, by shape even. In the field of agriculture, for the management of crop, for the management of diseases, and even for estimating the yield. And if you look at the applications of machine learning in the healthcare sector, you will find that there are countless applications of this technology, whether it is in radiology, pathology, oncology, any field you choose, you will find its application are numbers. But there are certain questions yet to be answered. For example, if you look at the prediction of the earthquake, I don't think there is any technology or there is any system to predict earthquakes so precisely. Weather forecasting. Well, in India, you might have experienced sometimes that IMD says that the day will be shining, but ultimately you get the rainy day. And contrary is also true, that if it is predicted as rainy day, there is a sunshine. And if you look at the tsunami of 2004 in Kerala, it did come. And the miracle was that there was casualty of the human beings, but the casualty of the animals was minimal. Why? Probably the human beings, they don't have the technology as such of predicting this earthquake, the tsunami side of it, but the animals, whether they are elephants, they are the cats, they are the lions, they could sense maybe the low frequency, high frequency vibrations. Somehow they could sense and they ran away from the site and could save their lives. Now today, when I see this deep learning, which in any case, it is a new term for me, I think there is a solution of prediction, correct prediction of the weather forecasting or the earthquakes by this deep learning. And I presume that deep learning is probably the integration of a large number of data and its analysis. I recall a situation when I was with the Department of Science and Technology. See, the prediction of the weather forecasting was based on maybe 7 parameters or 8 parameters. And to a very large extent, the low range weather forecasting was not there. But when one of the scientists, secretary of the Department of Science and Technology, he took a lead and involved a large number of institutions, probably 14 or 15 features were added to predict the rainfall. And I was amazed when all the 5 years, so long as he remained on the seat and he was the leader of the prediction, this rainfall prediction was accurate to a greater extent. Friends, when I see the application of the machine learning and deep learning, I would like to caution that any application will lead you for the development of a product or development of a tool. That means you are transiting from the knowledge base, abstract knowledge base, to the product base. I would like to caution that if there is a product, if there is a tool, please ensure that you protect your application, your tool, your product by the patenting or by the copyright. Anyway, there is a line of very eminent speakers. They will dwell on this subject of this deep learning and machine learning. And I once again thank you very much for inviting me to this FDP on machine learning and deep learning. In fact, I was keen to participate personally on the deep learning part of it because I am totally ignorant on this particular subject. But anyway, I convey my best wishes, my blessings to all of you for this successful event. Thank you very much.
Thank you, sir. Now, I would like to request Shri Akshat Goyal, sir, respected Vice Chairman, RKG Group of Institutions, to speak a few words.
Good morning, everyone.
Good morning, sir.
First of all, I'm sorry that because of me, the event is starting late. And first of all, I welcome Dr. Lakshman Prasad sir, R&D, RKG Group, Dr. D.K. Chauhan sir, Executive Director, RKG Group, Director, RKGIT, Dr. Somshekhar sir, and especially thanks to the Head of Department, Dr. Sachi Agarwal, and the faculty of our CS department to organize such event in this time of crisis. Because, see, when we talk about the applications of machine learning and the title of this FDP, it's involved in our day-to-day life. Why I'm saying that, if when we talk about the applications of machine learning, so what we are doing right now, virtually we are presenting all things. So it's a part of machine learning, applications of machine learning. The social services is a part. The social media services is also a part of machine learning. The topic is really nice, as Dr. D.K. Chauhan sir said, that it's a future. It's a future, and it's a future for everyone. Why I'm saying that? See, before that, before this pandemic, when we talk about the online things like virtually meetings, and focus on e-learnings. So everybody used to be like, we will do it or not. We don't know, because we were in that criteria. We usually have a physical movement and physical classes. See, I will say that no, nothing can change the physical classes. That is a thing. But due to this pandemic, it tells us the importance of a e-learnings, or it move on a social platform. Right now we have a virtual FDP. So might be if there was no pandemic, so might be we are having physical FDP. So we need to understand the importance of a social platform, whether it's a e-learning classes or it's a virtual thing. The best part for this, see, if we have a physical FDP, so might be the number of participation might be down, but due to this virtual thing, the number of participation is so high. Like I really congratulate the CSE department. They have done a great thing by organizing such kind of a event. And I was going through the list of eminent speakers also, and it's really it's really give the motivation by learning from such specialized persons. And the life is just for the learning thing. In life you have to learn from every part. And in the end, I will just say that I know that this FDP will be going great. And in the end, I will also congratulate all the CSE coordinators who have give their hard work to organizing this kind of an event. Thank you so much.
Thank you, sir. Thank you so much for your kind words. Now, I would like to request Dr. Amit Singhal, Coordinator Second Shift and Convener Technical, to propose vote of thanks. I request Dr. Amit Singhal, sir, to propose vote of thanks.
Chai ma'am, I think Dr. Singhal is on mute.
Amit sir, can you hear me?
Chai ma'am, I think he is not in the session, so I think he has joined back. So, Amit sir?
Hello.
Yes,
Hello.
sir, you are audible.
My voice is audible?
Yes, sir.
Okay. For some reasons, I think that was unmuted. Good morning, everyone. Honorable Vice Chairman, sir, respected Group Director, Dr. Lakshman Prasad, sir, Director, Dr. V.R. Somshekhar, sir, Executive Director, Dr. T.A.K. Chauhan sir, today's most valued invited guests, participants, ladies and gentlemen. I am highly honored and lucky to have the opportunity to give a vote of thanks on this special day. I, Dr. Amit Singhal, on behalf of the Department of CSE, RKGIT, and on my own behalf, extend a very hearty thanks to our esteemed speakers who took the time out of their busy schedule and shared us with their pearls of wisdom and knowledge. We are truly humbled by their presence. I wish to express my gratitude to our group director, Dr. Lakshman Prasad sir, director, Dr. D.R. Somsekhar sir, for providing this opportunity and support to organize this 5 days event. I am very grateful to our executive director, Dr. D.K. Chauhan, Dean Student Welfare, Sri H.G. Gargi, Dean Second Shift, Dr. Punichan Srivastava, for giving us this continuous encouragement to organize this event. The objective of this FDP is to introduce the participants to the world of machine learning and deep learning and give an insight into how and where it can be used. This will prove to be an eye-opening session for beginners and middle-level researchers, and also aimed at imparting the skill required to handle different tools and technologies that are useful during the entire process of research and scholarly communication of various applications of machine and deep learning. This FDP is intended to orient participants towards developing their own research plans, paying due attention to their stage of research. More than 2,500 registrations and more than 700 colleges and universities from India and abroad are participating in this FDP. This is a huge success in itself. I heartily congratulate all the participants for their active participation in this event. An event like this cannot happen overnight. The wheels start rolling weeks ago. It requires planning and a bird's eye for details. No event can take shape without a hard-working and dedicated team. It was the dedication and enthusiasm of our organizing team which make this FDP a huge success. So I extend a big thanks for making this event successful with your contribution. Above and beyond all, let us not forget the backbone of this grand FDP. We have been fortunate enough to be backed and backed being our pillars for support. I would like to thank Dr. Sachiv Gupta, convener of the program, Dr. Lalit Kumar and Mr. Gaurav Agrawal, co-convener of the program, for their wonderful job and research-oriented approach. Furthermore, let us have a special recognition for the audience who remained patient throughout this inaugural session. Let us have a big round of applause for our lovely audience. Thank you. Thank you so much.
Thank you, sir. The theme for today's session is Basics of Machine Learning and Hands-on with Python. The session would be conducted by Mr. Ashish Shukla. Mr. Ashish Shukla is currently working as data engineer at Hitachi Vantra. He gave summer training to 40 plus students and has conducted 3 weeks workshops on major technologies including Python, Flutter, Django to name a few. He has worked upon major projects including providing solution for virtual tour of railway stations and has also mentored team Hex Speaks to the finale of SIH 2019. So without further delay, I would like to invite Mr. Ashish Shukla to begin with today's session. Mr. Ashish Shukla.
Hello, everyone. Good morning.
Morning, sir.
Thank you, Chair, ma'am, for the introduction. Please let me know when you guys can see my screen. Is my screen visible?
Yes, sir.
Okay, thank you. I hope everyone is doing fine in this pandemic. So without further ado, I guess let's just jump right into the topic that we have we're going to be discussing upon. The session will be, this session particularly will be primarily based on the basics of machine learning. We'll try to cover as much breadth as possible of the topics available in machine learning. We won't be going into deep in any of the machine learning models or whatsoever. So I have provided a link here. Please just, I request all of the participants to go on this link and follow this sublink so that they can access a live environment where they can execute all of the code that I am executing in my presentation. So it will be easier to follow along to whatever I'm saying in this presentation. So let's see what we'll be talking about in this session. Initially, I'll be talking about some of the basic theories related to machine learning. Don't worry, I will try not to bore everyone as much as possible. After quickly skipping over this, we'll move on to the 7 steps of machine learning. And we'll do some hands-on using Pandas, Seaborn, and Scikit-Learn. And we'll conclude the session with some of the problems that we are facing in industry related to machine learning. And maybe if the time permits, I will also discuss on the things that I'm currently working with. Once you guys will follow that link, you will be greeted with this kind of setup. Please just go ahead and click on this one. Wait for a while. It will load the screen where you can execute the code. You can do it on your mobile devices as well. I'd highly encourage all of the participants to follow along using this link. So just to give you guys an example, you can just go ahead, try print hello world here and execute the Python code as we talk along. Okay, so let's just start with the learning problem. Now, why we were talking about the learning problem, machine learning and artificial intelligence in general is actually a cross-domain subject. It's not really something fundamentally related to computer science. It borrows a lot of concepts from neuroscience, especially biology and psychology. So we are all familiar with what machines are in the machine learning. We know machines refer to computers. The learning is the catchphrase here. So let's talk about the learning. So what is learning? This is a definition that I usually give for learning without being a lot inaccurate about it and not making it overcomplicated as well, like Thorndike and other psychologists that you may have come across. So I define learning as a process of getting good at something by acquiring knowledge through experience with your existing knowledge. Let's take an example for the same. Let's go back into the time when we were kids and we were learning how to multiply numbers. So what was the task at hand? We just wanted to learn how to multiply numbers, right? What was the knowledge that we wanted to acquire? How to multiply numbers. What was the existing knowledge that we had? I suppose that if someone is going to learn how to multiply numbers, he knows how to add numbers, right? How did we learn that? We gained the experience by solving multiple questions. So we used to have a long notebook where our teachers would write 3 cross 3 and then would tell us, okay, it's 9 and all that. And they also told us that this is a repeated addition. And then as we followed along, we developed rules of our own by remembering some tables, maybe using some formulas like a plus b whole square and all that to simplify our multiplication process. Let's say someone tells you that you need to multiply 204 by 204, and maybe you would treat it as 200 plus 4 whole square and expand it along the way. But so your process of multiplying numbers evolved based on the existing knowledge that you had. So that's essentially what learning is. And to be honest, we kind of keep on building upon this process of even something as fundamental as multiplication as we keep on acquiring new existing knowledge. So how can we basically define this whole framework of learning, how to learn? It's just a two-step process. First, you take up a task, which was multiplication. Now, the second step is something like a tree, which has the nodes where we will be making decisions. So I guess it would be wise to call it a decision tree. So we take up the task and we say, is the solution known? If the solution is known, then just go ahead and look up the steps and formula and you're done with it. If it is not known, or if there is not a predefined steps or formula or fixed steps or formula to solve a certain task, then we ask ourselves, do we care about finding the solution? Just like twin primes and all that, we don't care about that, so we might just give up. Otherwise, if we actually care about it, we take many instances of the problem and try to find a solution with your existing knowledge. Now, your existing knowledge helps you in finding the patterns in the instances of the problem that you have faced, so that you can come up with a generalized enough solution that can help you solve other unseen problems as well. Believe me or not, but this is the core philosophy for all of the machine learning and deep learning that we are doing in any domain. As we go along the session, I'll try to drop parallels with some practical machine learning examples with this particular definition, so that it makes more sense. Okay, let's talk a bit about what is machine learning now. Now, as I said, machines are just computers, and computers are not really like humans. They don't have fuzzy built into their neural system. Computers are very deterministic, and to be honest, they are very dumb. They just do what you tell them to do. So how can we define a process of learning for a machine? Now, machines are good at doing things what you tell them to do, like computation, for an example. So maybe we can take help of our friend mathematics to define a framework of learning for machines. So I like to define learning as a function that is y equal to ftx. T is the task that we have at hand, and our method to solve the task is defined as a function ft. The y is the outcome, and x are the conditions in which we are going to perform the task t. Now, what do I mean by the conditions? The conditions here are the features of input, basically the characteristics of input. Let's say you were going to build a juicer. The input would be something that you want to squeeze the juice out of, right? And the output would be your amount of juice, and your function here would be maybe just a metal box that you keep on changing and changing, keep on making modifications and in order to convert it into a juicer. Now, the things that you are putting inside that metal box, they have certain characteristics, like the softness, the amount of liquid in them, and maybe size and shape. Now, these are the characteristics of the input that you're providing to your raw, dumb, to be honest, raw and dumb model, and you're predicting an outcome out of that. Okay, So let's say y actual is the outcome that we got after we performed the task under the conditions X. Again, the conditions are the characteristics of the input. Okay, so what are the possible three scenarios that we can have? Let's say y expected is the expected outcome. Okay, and now the actual outcome is the outcome that we are getting after plugging in the input in our function, and the expected outcome is the actual outcome that we should have. So there are three scenarios. We exactly know what the expected outcome is for all of those conditions. We don't exactly know what the y expected is, but we can at least point it in the right direction, like it was good or it was bad. Or the third scenario is that we don't know anything about it. So the scenario one is supervised learning. Scenario two is reinforcement learning. And the scenario three is our unsupervised learning. Most of the things that are happening today are related to supervised learning, or at least the most common applications of machine learning that we come across are related to supervised learning. Now, let's talk about some terminology here. The input characteristics.
Ashish sir, I am audible?
Yes, sir. You are.
Ashish sir,
Hello.
so that it will be visible to all the participants.
Hello, sir. I could not hear you. Can you repeat that?
Ashish sir, the font size is not visible to the participants.
Okay.
So I humbly request you kindly increase the font size.
Is it visible now?
Sir, if possible, please increase a bit more. Yeah. Thank you, sir. Thank you.
No problem, sir. Thanks. Thanks for letting me know. Okay, so let's talk about some terminology here. The conditions that we were talking about, the X, the input variable, the characteristics of the input variable, those are called features in machine learning terminology. The outcome Y that we are getting is called the target variable. And the function FT that we had is essentially the machine learning model. Now, the machine learning model is not the actual solution. It's some mathematical formulation that tries to mimic the actual solution as close as possible. Sometimes it's good enough that it can just completely mimic the actual solution, and then you get a really high accuracy. But sometimes it's not that good, so you don't get that good accuracy. No, just some redundant theory here that I'm pretty sure that you're all aware about. The supervised ML, as I mentioned, that it's the most important one, and indeed this is the one that we'll be discussing today, mostly in our practical walkthrough. The machine learns by minimizing the difference between the y expected and y actual. Some examples of the same are decision trees, linear regression, logistic regression, support vector machine, k-nearest neighbor algorithms. KNN is an exception here because there is unsupervised KNN as well. Now, what about unsupervised ML? Probably this is the third most used thing. Reinforcement machine learning is used a little more than unsupervised machine learning. But in unsupervised ML, the machine learns by trying to find out relation between the examples based on some metric. So let's say you had a task at hand where you just wanted to group some things together, then you would use unsupervised machine learning, and you didn't know anything about the target variable or anything. So then you would use unsupervised machine learning algorithms. What about reinforcement machine learning? So the machine learns by adjusting parameters based on the expected outcome. Q-learning, QRDQN are great examples of it. Whenever you see some AI agent being built that learns how to play chess or Go or such games, or maybe agents that drive cars and all, they are basically trained using reinforcement machine learning algorithms. Now, don't take my word for it. For the driving cars examples, because there are a lot of other types of machine learnings involved as well in driving cars. So now comes the most juicy topic of the whole session. That is 7 steps of machine learning, and let me assure you that these are actually the 7 steps for practically any problem that you're going to come across for machine learning area. So let's take a problem to solve with machine learning. And as Gaurav also told me that there will be a lot of professors and students attending the session, I thought that it would be nice to not go with the Boston house price prediction data set, which is quite boring. And let's go with predict a student's performance in final exams. So we'll be exploring these 7 steps of machine learning using Python. I highly encourage everyone to use Python, even if someone suggests you to use something like R. Please go with Python. It's much more practical than R. Maybe the initial learning curve is going to be a little steeper, but as you'll go along, within a matter of month or two, you will find it much more practical to use than R. So let's talk about the first step. By the way, before we start with these 7 steps of machine learning, the reason why I shared with you guys the link that I shared in the beginning is so that you guys can just go ahead and explore the content yourself as well. So that you don't really depend on the font size on my screen, or maybe the way that I'm executing the code, so that you guys can do it on your systems as well. I'd suggest for at least this section to keep on executing the code using this link on your machines, and just listening to my voice, if that's practical enough for everyone. So the first step, data collection. So what did we say in this starting? We need a lot of examples to learn from. Those examples are essentially our data. So you have some input characteristics, and maybe you have some output or some target variable. Okay, so you just collect examples for the machine learning model to learn from. And I know it seems rather dumb, like this is going to be the easiest step, but trust me on this one, this is by far the most important step in machine learning. If you mess this up, you're gonna have a really hard way down the road from step 2 to step 7. Indeed, just 2 days ago, we faced this problem in my company as well, while exploring a problem where we were getting really low accuracy because the data collection was not done properly. Rather, it was something related to sampling bias. Maybe I'll discuss it further if the time permits. So where do you actually look for data? There's this amazing website, Kaggle. Go on this website, try to look for the data related to your problem. Second is this UCI machine learning repository. Third is GitHub. And the fourth one is your best friend, Google search. And if you still cannot find the relevant data for your problem, then sadly you're out of luck and you need to collect the data yourself, or pay someone to collect the data for you. Now, you must be thinking that I'll just pay someone like 2,000, 5,000 rupees. they'll collect the data for me. Let me tell you that the cost goes as high as millions, because those are the reasons why data is actually called the oil of 21st century. There is one particular type of data named petrophysical data in the oil drilling domain, and that involves a lot of machines using LIDAR technology and radioactive the substance monitoring technologies to collect the data. So the data cost is really high. Depending on your problem, this step might be very trivial, or this might be the toughest that you will ever come across. Okay, so the data that we are interested in for doing a student student grade prediction is available at the UCI. Just go to this link, you'll get a zip, download this zip file and extract it in a folder. I've already done all of it on this link so that you guys don't have to do it. So this zip contains a CSV file. Let me actually show it to you. What all files does it contain? So it contains these 3 files. One named is student, one named is student math, and one named student for. This was a data related to the students' performance in mathematics and Portuguese. So this file contains the data in mathematics for students, and this file contains the data for Portuguese for students. I guess we are not really interested in Portuguese performance of students. So let's go with the mathematics. Now, for the second steps of machine learning, that is your data preparation. What do we do in the data preparation? There might be some bad examples, and and you need to convert those examples to a format that your model can actually understand. And maybe you have a lot of unnecessary noisy inputs, and you want to filter out what all are actually the useful inputs for my model. You can also do some exploration of the data to find some hidden insights in the data, which we will do. So this step involves something called data wrangling and exploratory data analysis. We will discuss about both of these. So our friend in this step is the first library that we are going to be using, and that is Pandas. So just to demonstrate you guys the power of Python, let's just search for CSV files using Python. This is a code snippet of Python. I am a little short on time, so I won't be going into the basics of Python. Instead, I'll try to build it up as we go. So what this line particularly means is that there is a library named pathlib. You import a class named path from it. Now, what path class does is it provides you some functionalities related to the paths of directories and files on your file system. So I know that I have the CSV file in the same directory. So what I'm going to do is I'm going to create a path object for the current directory. Dot here refers to the current directory. I'm going to recursively search globally for all of the files that have a prefix student. I don't care what they have after a student, and they have a suffix .csv. So let's just execute this one. Hold Control and hit Enter in order to execute the code. So what about this line? So there are a lot of files here. I want to get the next file. So I again hit Enter and I get this student math. Let me hit Enter once again to demonstrate that it's actually going through all of the files. So this time it went to the next file, which was student4.csv. But again, we're interested only in the mathematics data. So I'll execute this cell again and this cell once more. So now this is a variable. Unlike C and other languages, you don't really need to declare variables in Python. You have a path variable that contains this information. We have just printed path and it contains the path for the file, the CSV file that we are interested in. Now CSV stands for comma separated values. But we'll see that the name and the body of the file are actually not in sync. So let's read this file into a data frame. Now, what is data frame? A data frame is a general data structure that is good at handling tabular data. And what do I mean by tabular data? The kind of data that you see on Excel, the kind of data that you see where there are rows and there are columns, that kind of data is called tabular data. And Pandas is actually built around this data structure. To be honest, not just Pandas, there are a lot of other technologies that are built around this data structure, like PySpark. PySpark is built around RDVs, which in turn provide you a wrapper over the data frame. Some new emerging technologies like Wix and Dask are also built around this. So this is one particular thing that is interesting to learn more about. So it's as simple as this. Reading a file, a CSV file in Python as a data frame is as simple as this. You just do import pandas. Again, pandas is a library that you're importing as a name alias PD. Now, this is one standard that people follow. They import pandas with the alias of PD. They import NumPy with the alias of NP. And we'll explore some other of these aliases. Just to make sure that you guys don't misunderstand it, I'm going to remove this and write pandas here. It will work exactly this in the same manner. But as you guys can see that it's not really the best looking code if you have a lot of pandas written all over it. So just go ahead and import it with the alias of PD. This PD namespace has one function named read CSV. You provided the path, relative or absolute otherwise, and it will read the content of the file for you. Now, what is this? These are certainly the row numbers. These are supposed to be the columns, and these columns were supposed to be separated by comma, but we see that it's separated by semicolon here. Now, I intentionally chose a file which did not have separation using comma. Otherwise, it kind of makes us confused that it gives us sort of a misconception that CSVs are always going to be comma separated. No, it's indeed not that. The CSV got its name from the most commonly used separator, but it can be tabs, semicolons, or anything for that instance, to be honest. So there is an argument that this function takes. This is called sep. We have a separator with a semicolon here. You just provide this separator into it, and it will return you an object of that data frame. Makes all the sense to name the variable as df, standing for data frame. And you want to just print 5 rows of that data frame in order to see what your data actually looks like. So our data actually looks like this. There are some row numbers. This comes by default in Pandas. There are some school, sex, age, address, fam size. What is this? P status, MEDU, FEDU, MJob, FJob, and FAMREL, free time, and everything. I'm pretty sure that everyone must be getting confused about it. So whenever you acquire the data from somewhere, and it's an important thing that whenever you acquire data from somewhere, it should have a data explanation associated with it, which should tell how the data was acquired, how the what all the column names actually mean. So there is one file that I showed you all. There is a text document, and that document has all of this information. So apparently mjob refers to, medu refers to mother's education, mjob refers to mother's job, fjob refers to father's job, and you can read the rest of it. Okay, so one more sub-step in this second step. Let's explore a little bit about the types of data. Now, we know that there are certain data types in our programming, like in float, double, uh, characters, strings, maybe, which are some complex data types. But what about the data types in general that we see, that we come across in our daily life? So there are mainly three types of data. It's either going to be numerical, or it's going to be categorical, or it's going to be ordinal. Now, the numerical data is usually gathered by doing some measurements. Now, measurements need not involve a measuring tool. Like, you don't need to have a vernier caliper measuring a student's absence. You can just note it down on your register, and that's all. That's also a measurement that we are taking for a student's absence. Now, the measurements can be discrete or they can be continuous. Just like I mentioned right now, the vernier caliper, let's say you were taking a measurement for a breadth or height of something, then that is going to be a continuous variable. It can be 1.67 or something as well. If it is a discrete variable, it's always going to occupy all of the integer values, like number of people that dislike Facebook, +1 from my end here. Categorical variables. So let's say here are the good ones, there are the bad ones. So these are the two categories that we give. So these kind of variables are called categorical variables. Sex is one of them, where you segregate people into females or males. The third one, ordinal. What ordinal means, people get often confused with numerical discrete and ordinal. Ordinal can be a categorical variable. It can be a numerical discrete variable as well. The thing is that it basically defines the priorities. Let's say I was just talking about good and bad. They can be a rating that we can give from 1 to 5, where 1 stands for very bad and 5 stands for very good. 3 stands for okay, like not so good, not so bad. So those are the ordinal variables. Whenever you want to basically establish a priority, then we go for ordinal variables. Okay, so what are the best suited data types in terms of programming to uh, to 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 basically use these represent these? Uh, we have the numerical discrete, as I mentioned while explaining the types of data. We can have integers used for this. They can be a numerical continuous, which can be represented using floats or doubles or decimal. We can have categorical variables. They are always represented using strings. And we can have ordinal, which can again have a string or int. Let me correct the slides. Now, this categorical variable can also have one special data type in Pandas, which is category. We'll explore it. So our machine learning algorithms or machine learning models are actually based on maths. So there is only one thing in all of these data types which doesn't quite fit into our mathematics, and that is strings. You cannot add two strings without defining a rule prior to that. Now, all of the people who are thinking that apple plus orange is equal to apple oranges, that is a concatenation, not an addition. So you cannot really perform arithmetic operations using strings, but our machine only understands mathematics. So we need to convert all of this categorical data into our numbers. So when we convert something from one form to other, especially if it relates to the data, then we call it encoding. Now, we can have three types of encodings. We will be discussing only the first two. Third one will be discussed probably in an NLP session, I'm sure that a session would be dedicated in our line of sessions for. Now, what is integer encoding? You just assign an integer to all of the categorical variables that you have. Like, let's say you had apples, oranges, and mangoes. You'd say apples is represented using 1, oranges are represented using 2, and mangoes are represented using 3. Similarly, I have given an example of F and M here, which is females and males. Now, what about one-hot encoding? This is basically replacing one categorical variable using a binary vector. Now, what do I mean by that? We'll be able to understand it better when we'll see the example. So let's go into the EDA. Please keep it in the back of your mind that we will be learning more about one-hot encoding as we go in the phase of EDA. So what does exploratory data analysis actually mean? It's just exploring the data and doing some analysis on that. Now, let's see some general exploratory data analysis, some basic things, like how much data do we have? You had the data frame object from the previous slides. You just execute this thing called df.shape, and it tells you how many rows and columns do you have. Do we have any of the data that is missing? You do a df.isNA.sum. Now, what df.isNA returns you is a mask object where it tells, okay, NA stands for not available, which is essentially something that's missing. So you do df.NA is NA, then you get false, 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 true, true, true. True will be wherever the data would be missing, and false would be wherever the data is not missing. So when you do a dot sum on it, what it will do is it will just sum all of those false and trues. Now we know that false equals 0 and true equals 1 in our integer representation for Boolean variables. So when you will just sum it up, it will give you a count of all of those variables, all of those occurrences for a particular variable where the data does not exist. And apparently the data that we have is really good, and it is not missing any of the data. It's really, you'll barely see that all of the data exists. You'll have to do some things in order to get rid of those missing data rows, or maybe doing something like imputation. We won't be discussing imputation here. That's a little high level topic. At least that does not fall under the very basics of it. So what types of fields do I have? In order to see this, what I can do is just access this property on this data frame object, which stands for data types. Now you have school, which is an object type. You have sex, that is an object type. You have age, that is integer 64. Object here stands for string. So all of the string data types that you're going to be having, they are going to be represented with object. Okay, so let's say you want a summary of data. You want the maximum, minimum values per column, values by quarters, and other knowledge about your data. So what you would do is just df.describe, and this is going to give you a nice little description of your data, how much data exists, what is the mean of the data, the standard deviation in the data, the minimum and maximum value of for that particular feature, the values per quartile, and among such. Now, how do you actually visualize the relationship between variables? If variables are numeric, like here, these are the variables. Well, before we go any further, I would just like to make sure that everyone understands that our student was the input for this problem, and the age, the mother's education, father's education, travel time, study time, failures, and everything are essentially the features of that particular students, that the characteristics basically of that student. And what we are trying to predict here is G3. So this is our target variable, and this is the final grade for a student. So how to visualize the relationship between variables? Again, if the variables are numeric, we can use line plots, which is nothing but having one variable on the x-axis, one variable on the y-axis, pointing all the dots, connecting all the dots. Some bin plots, like histogram, where you take a frequency for a bucket and then you plot it. You can have a two-dimensional histogram as well, which is known as hex bin. It's not really accurate to call hex bin a two-dimensional histogram, but that's pretty much the closest analogy that we can draw here. Now for scatter plots, what are scatter plots? Let's say you did a line plot, you plotted all of those XY points, but you didn't connect the lines. That's all that your scatter plot is, to be honest. Now, Pandas is sure helpful for analyzing all of the data, but it's not really that helpful if you want to plot the data easily. So let's onboard one more of our friend, that is C1. So you import the library again in the same manner. This is definitely optional, and I won't be talking about this library. C1 is based on matplotlib, and this library will only be used to manage the figure size. So let's try doing a line plot in this. This is the data that we had in the data frame. We remember that there was some X variable named absences right here. And then we had a target variable G3. We wanted to plot a relationship between them. We wanted to plot a line plot. We would do a SNS.lineplot. We'll give X is the absences, Y is the G3, and the data that we have is in our DF variable. Again, you can always import it as Seaborn and use a Seaborn.lineplot. That's also going to work, but it's a nice habit to import import the libraries with a specified namespace. And trust me again on this one, that all of these libraries namespaces are standardized. Like Seaborn is always imported, as the namespace alias SNS. Similarly, the pyplot is always imported with a PLD alias. Similarly, there is one more library, and that is NumPy, that is imported with NP alias. And we should remember that Pandas is imported with a PD namespace. You will be seeing a lot of SNS dot and PD dot in the code from this point, and that essentially means that we are using a function from those respective libraries. So if variables are ordinal or categorical, then what do? We can use bar plots or swarm plots or count plots to establish a relationship between them. Or rather, I should say, to visualize the established relationship between them. You want to do a bar plot, you just do a SNS.bar plot, you give the X, you give the Y, you give the data as your data frame, and there you go, you have a bar plot. You want to do a count plot. Now, what count plot means, before I talk about how to plot count plot, what count plot means is that you have certain values for this variable. Like for free time, this was an ordinal variable ranging from 1 to 5. And this just plots the number of rows that have that particular value of that variable. Okay, so there is your count plot. Now let's talk about something more important, that is correlation. Now what correlation means is that one variable depends on the other variable. So, or rather I should say, the change in one variable depends on the change in the other variable. Now, it can be negative or positive correlation, but both of them are equally important for our use case. So what can we do to visualize the correlation? We can use the heat maps. Now, what are the heat maps? Heat maps are nothing but just a 2D grid where you have a lot of colors, where the color denotes the intensity of the plotted variable. And how do you find the correlation in the first place? Forget about plotting it. So you have this df object, you do a df.core, and it will give you one new data frame which will have a correlation matrix. Now, what correlation matrix means is that with the age variable corresponding to the age variable, this is the correlation coefficient for Pearson. Corresponding to the age variable against the mother's education, this is the correlation coefficient. Now, in the correlation matrix, this diagonal is always going to be 1 because every variable always positively correlates with itself. Also, the mother's education to age and here mother's education to age are going to be same. So you can essentially just leave out the upper triangle of this matrix. So this is how you would visualize the whole thing. Now, if you pay attention, then we don't have a visualization for the categorical variables that we had, like sex, for example. We don't have a correlation against the gender here at all, and that is because that's not numeric. So that kind of solidifies our assumption that we need to convert everything into integer or basically number representations in order to do some machine learning stuff on that. So again, getting back to the thing that we were talking about, which was the encodings. So let's see, how can we do integer encoding? So what this chunk of code actually means is that you select the data types Basically, you select the columns with a certain data type. Let me show you the outputs here. So if you do a df.select data types object, it's going to give you all of the columns that have this data type. Then this dot apply lambda. Lambda function is nothing but an unnamed function where it's going to take certain inputs. It's going to have one line of code and it's going to return the value. So you'll go through each of these columns, convert those columns types to a category type, access the cat property and the corresponding codes property on it, and you're going to return that value. And you're going to apply this function for all of the columns. So that's all that the code is saying. Now we are making a copy of it named IDF. Now what IDF here means is that this is a data frame that's encoded with the integer encoding. You want to replace all of the columns for the columns with the encoded columns, then you just go ahead and do this. This replacement is essentially just a just a data frame. Data frame has this value, this attribute columns. So you replace all of the columns with the corresponding values here, and there we have a data frame nicely encoded with the categorical variables integer encodings. So as you can see that previously we had this x as fm, now we have it as 10. Now getting back to one hot encoding ones. Similar to what we did earlier, we're going to take a copy of our data frame. After getting the copy of the data frame, we're going to execute this little function on Pandas, that is p.getDummies. And we're going to give our data frame as input to this function. And it does something something a little weird. So nursery had two values, or maybe I should talk about this one. So internet has had two values, and those were yes and no. What it did was it replaced that one single column with two columns. So I can say that one column was replaced with a vector, a binary vector with ones and zeros. So it has one value where that particular value was no, and it has one value for yes where that particular value was yes. So let's say it was for activities. Again, we had yes and no here. Here the activities value was yes. So it replaced it with two columns. Again, activities no and activities yes. Because the activities value was no here, so it replaced it with a vector of 1, 0. Let's say it had no, yes, and maybe, then it would be 1, 0, 0. It would replace it with a vector of 1, 0, and 0. I hope that makes sense. If it doesn't, then just go ahead and play with the notebook a little, and it should make sense then. So let's do some EDA specific to our problem. So students' distribution on final grades. We'll just do a count plot on it, and we can see that most of the students are scoring just the average marks, and there is barely one student who is scoring in full. Those students who come daily to the class score higher, and contrary to the popular belief, the students that come daily are indeed scoring at par with the students who don't come at all to the class. Maybe it's because the students who come daily to the class don't do self-study. And the students who are taking some time off the class are actually scoring the highest. Now, these are some questions that we're not really interested in primarily, but it's nice to gain these insights from the data. If you're ever presented with a data set, try to find as many business insights as possible rather than just accomplishing the goal. The goal of data science is not to solve one problem. The goal of data science is to find the problems and solve them. So even if you're presented with some prediction problem, try to do some exploratory data analysis on that and try to find some hidden insights from the data. Similarly, let's see two more examples that I have given here. Let's do a swarm plot here. And for replying this question, do students who have internet at home score higher? And yeah, it makes sense because maybe in these pandemics like Corona, only those are the ones who can study. Does romantic relationship affect a student's score? I think we don't need to see the graph for it because we know how the graph is going to look like. And yeah, it does affect. Okay, so do previous grades relate with the student's final grade? Now, see that we're not trying to establish a relationship here. We're not trying to visualize a relationship here. We're trying to see if at all it relates with the student's final grade. So the wise thing would be to do a correlation. And they are strongly correlated. Anything over 0.8, whether minus or positive or plus, is strongly correlated with the G3. Now again, it would have returned a data frame where it would be a square matrix. But we are only interested in the correlations corresponding to the G3. So we just extracted that column out of it. And there you go. There you have all of the correlations. So these are the three variables that are strongly correlated with each other. Now, does parents' education affect a student's final grade? Again, it's wise to plot the mean of it, or maybe you can just visualize it using such query. What this query means is that you have a data frame, just extract these columns out of it because I'm only interested in mother's job, father's job, and the final grade. Let's group all of these rows based on the mother's job and father's job and take the mean out of it. This is my mother's job, this is my father's job. If they are both at home, maybe they can pay more attention at my studies and I will score higher. Rather than if my mother is at home and my father does some other job. So one insight that we get from here is that people who are working in health sector have their children scoring the highest. So now the last question, that which features are really important for our prediction? Obviously, the features that highly correlate to our target variable are going to be the ones that will be most essential for our prediction problems. So if you remember, then in the general EDA, we plotted a heat map. And I also said that it doesn't matter if the correlation is negative or positive. There needs to be a correlation. So what we're going to do is we're going to plot a absolute value of the correlations. So there is a heat map of it. So what this visually tells us is that all of the rows that have dark color are actually not correlating, and the lighter the color of the row, the higher the correlation is. You can just ignore the G3 because it's always going to have one correlation. Again, repeating the same thing, every variable correlates perfectly with itself positively. So let's do a sum of the absolute values of all the correlations of all of the variables with the G3, that is our target variable, and see what all columns, how many columns have their correlation greater than 0.1, and that's indeed 9 here. Let's try to see what all columns have the values greater than 0.1, and it's easy to see it using this bunch of code where we're just taking the absolute value of the correlation coefficient, seeing whether it's greater than 0.1 or not, extracting the indices from it, and plotting, and then just removing G3 from it, because this is not really something that, it doesn't really make sense to have a target variable as a feature and then predict it, because that's always going to be a perfect prediction. So these are all the important columns that we have. Mind that we were using a data frame that was not encoded. So we're going to do the same plot, but this time we are going to use the data frame which was one-hot encoded. Let's see if we get some more features here. This library is just for changing the figure size. If you don't use this line, the graph is going to be a little small. Let me execute all of the lines that I hadn't executed earlier. So apparently I didn't execute this line, and that's why I was getting an undefined variable exception there. And there you go. Now we have a heat map for it. But again, you can see that it's quite a small, right? So let's just go ahead and comment this line, plot it again. And now we see that we indeed have some more features, and that makes all the sense, because after one-hot encoding, the number of columns has increased. What this line tells us is, again, the same thing that we saw for the unencoded data frame, and it's also telling us what all features are there that have correlation coefficient greater than 0.1. Previously, we had 9, and now we have 21. So that must mean that we're doing something better, or maybe we should use this data frame. Turns out for this problem, yes, that is true, that this one-hot encoded data frame is going to perform significantly better than the non-encoded one. But more often than not, more features do not mean that our model is going to be better. There is something called as overfitting that we will not be discussing in this session. And what overfitting essentially means is that the machine learning model that you have trained has learned specifically the problems that you gave it as an example. It's like a student who doesn't know, who has crammed up all of the problems that you give him for exercise, but when you put him to test, he scores 0 because he has crammed up all of it, right? So that's overfitting. So now we need to test and train our model. This step for splitting the data into test set and training set is also involved in our second step itself, that is data exploration and data wrangling. Now we need to randomly split the data frame, and usually we split the data in 75 to 25. We use 75% of the data in order to train the model, and 1/4 for testing. Again, it makes all the sense, right? Just take it from a student's perspective. We teach them a lot, and then give them barely 20 problems in order to test whether whatever they have learned, they have actually learned it or not. Now, testing involves checking if our model is making predictions that are accurate enough or not. So we'll be using this library now, NumPy, in order to randomly split our data. What this line essentially is doing is it's creating a matrix of the length of the data, which is the number of rows, and seeing where all it has the value less than 0.75. This might be a little confusing at first, because some people might think that there would be a lot of values unevenly distributed, but turns out that the pseudo-random number generator that is used here has equal probability of prediction for all of the values. I mean, equal probability of outcome for all of the values. So here, this train and test is indeed going to have 75% values of the data frame for training, and the 25% values here for the test. Now we'll be exploring a little more on something called Scikit-Learn, and there are some functions that can provide us some helping hand in doing these things. But I thought that it would be nice to know how the thing works internally. Now let's see the test and training shape. It's exactly what we expect it to be. The test has 103 lines, and the training data has about 300 lines. Now choose your features and prediction variables. So this is our target variable, that is G3, and the important columns that we extracted after doing that correlation are the X. And by X, I mean the features. And by features, I mean the characteristic of input. Now let's try filtering our train and test data with X and Y columns. It's as easy as doing this, because we already have the train and test in our data frame format. We can just do a train, pass the X, which is a list of columns that we want to extract. We can do a test, pass the list of columns that we want to extract. Do a dot head on it in order to see what all variable values are there inside those columns. I mean, inside those data frames. We won't be discussing these in this session because of the time constraints, which is feature selection. This is one very important step in this data wrangling. I highly encourage all of the participants to go through the topic mentioned here in this particular cell. So finally, we are at some prediction and doing some real machine learning stuff here. So now we need to choose a model. Now, there are some criteria based on which we choose the models. It wouldn't be wrong to say that you can essentially just take up like hundreds of models, train your data on all of them, and just be done with it. Whatever performs the best, you just take that, and you're good to go. But training hundreds of models, as we'll see, that training hundreds of models takes a lot of time, and misfortunately, and data scientists don't have that much of computation power or time. So which kind of problem do we have? We have supervised, unsupervised, or reinforcement. Definitely we have a supervised problem, because we have the final score for the students. So we have the student scores as G3, and this is Y expected, and it's a supervised problem. So supervised machine learning algorithms or machine learning models are divided in two subcategories. One is called regression, and the second one is called classification. We do a classification if there is a categorical target variable. We do a regression if there is a numeric target variable. So which one do we have here? G3 is apparently numeric, so we can do a regression on it. Now mind that no problem is inherently regression or a classification problem. You can always convert a problem to a regression problem or a classification problem. Just like we have right now, we have a distribution of the grades of the students distributed from 0 to 20. And if we convert the problem in this manner, where we give grades to a student after binning their marks, like all of the students that have marks from 18 to 20 have grade A. All of the students that have marks from 15 to 17, let me correct the slides again. 15 to 17 have B grade. All of the students that have 11 to 14 C, and so on. Then it would be a classification problem, because your target variable, you have transformed your categorical, your target variable from a numeric domain to a categorical domain. Now let's just decide what all models we want to try out. As I mentioned in the starting, we're not going to be discussing specifically about any of the models in this session. So these are all possible machine learning algorithms and models that we have credits to Jason Brownlee. This is an amazing website to learn more about machine learning and deep learning. Based on my previous experience, which I'm sure that everyone will have if they just fiddle with a couple of data sets, I know that one of these algorithms or machine learning models should do good on our data set. So depending on the data, we can filter out a lot of machine learning models. To be honest, I know that it's this linear regressor and Bayesian regressor are not going to work fine, and decision tree is going to overfit. Nearest neighbor regressor is not really the most optimal here. So we should be doing it with only random forest, support vector, and multi-layer perceptron. But just to give you all a demo of how the things actually work, even if you don't have a clue about the internal workings of a machine learning model, just by knowing these small insights into the problem, you can actually land on a pretty nice result. So depending on the data, we can filter out the machine learning models. I highly encourage everyone to see at least the basic working of all of the models mentioned here. Now, how do we implement all these models? Certainly, you're not going to write the code from scratch in Python, and we have Scikit-Learn to the rescue. And to be honest, these three libraries that I have just mentioned, Pandas, Seaborn, and Scikit-Learn that we are going to use, you can attribute a lot of success and popularity of Python to these three libraries. Python is actually available since 1980s, if I'm not wrong. So the initial version is available since 1980s, but Python was not that popular and was quickly taken over by Java. But the reason of Python's popularity are the libraries and the syntactical sugar involved in the language, rather than the speed or anything of that sort. So let's try implementing linear regression first to familiarize ourselves with the API. It's as simple as this, really. You just do a from sklearn dot linear model import linear regression. This is the library that we have. This is a sub package. This is the class. You create a model object. This is the class. You put two parentheses ahead of it. You created the model. You just train the model. In order to train the model, you call .fit. You pass it the training data with the features here and the target variable here. Then you make the predictions. And after making the predictions, you can also score it. For a classification problem and for a regression problem, we have different ways of scoring the model's performance. Here it is the R-square score. We will be discussing about these various ways of scoring a model's performance later on in the step 6, I guess. So there you go. You're getting some score after training the model. Now, some of the people might be thinking that it was pretty fast, but it just took like what, 2-3 seconds. And the reason that it took 2-3 seconds is that you have just 326 rows. Imagine if you had 3 million rows, it would take 1,000,000 times, 1,000 times more time, or maybe 10,000 times more time. Yep. When you'll be implementing all of these models in industry, you will have a lot of data to train your models with. That's why I mentioned you cannot just take a lot of models and blindly train all of them and see which one performs the best. So let's get our models now. These are the 7 models that we talked about. We'll create a array that contains the objects for all of these models. All of these models come from different classes, different packages. And if you're unsure about which package my model will come from, just search random forest scikit-learn, and it should show you probably on the first result where this is coming from. So you could do a from sklearn.ensemble import random forest classifier. So now we have a list of all the models. Our models, if you can see that we haven't given really a parameter here in order to initialize the models. And when we don't give any parameters, Scikit-Learn itself gives some default parameters, which indeed performs very well most of the times. So let's try training the models now. Now, what does training mean? Training means nothing, but it's just showing the examples to our student to make it learn. So training is just feeding the examples to a function to let it fine tune its variable coefficients. This line is something that will make more sense when you will see the internal structure of how these machine learning models work. And in case of some instance-based models, neighbors, it just creates a data structure. It doesn't really fine-tune any variables coefficients. So we just want to train all of the models with the same data. What we're going to do is it's just a for loop. So for model in models, we remember that we had a list of models, and what this line is going to do is for the first iteration, it's going to have the first value of models list, which is going to be our first model. For the second iteration, the second model, third iteration, third model, and so on. So you just do a model.fit, and this line will execute if all of these lines have executed without any error or a break statement. So let's hit Control plus Enter, and it has completed training. Let's evaluate the model now. So we can always score a model's performance using model.score mechanism. So this will return you a value between 0 to 1, and the higher the value, the more accurate your model is. The definition of accuracy varies problem to problem. Here we have a regression type problem. So we'll be focusing on something called R-square score. as this cell says, sadly, evaluation is not so straightforward. We need to determine how we want to evaluate our models. More often than not, you will see that R square is not really the best metric for your particular problem. And in fact, for classification and regression, both we have drastically different ways of assessing the performance of our model. So we'll focus on some metrics commonly used for regression. The first one is just taking the mean absolute error. And it definitely makes sense if you just think about it. You see what is the deviation, what is the absolute deviation from the expected value of the predicted value, and you take an average of it. So that's your mean absolute error. And if you think about our problem at hand, then MAE makes more sense than any other problem. Than any other error metric. So we'll only use this metric if we want to penalize our model for big errors. Like if we don't want to, penalize our model for big errors. So if we think that the value, if it is off by 2, it's exactly twice as bad as deviating by 1, then it's a MAE job instead of a R square. MAPE is nothing but just a percentage error and absolute mean of it. This is often used for prediction, the forecasting problems. RMSE is something that comes by default. So you just take the difference between all of the values, the actual and the predicted and the actual ones. You square them, you sum all of them and take an average of it. After taking the average, you take the square root of it. So that's what it stands for. You take the root of the mean of the squared errors. So let's say we want to calculate the mean absolute error for all of our models. Then this is the way that we would do it. Scikit-Learn package has this sub package called metrics, which has this function called mean absolute error, which does this computation for you. You just need to provide it with the predicted values and the correct values, the expected values, and the predictions. If anyone is confused about this particular line, then what this means is that we have object. On that object, we are accessing a special property named class. And on that property, we have one more special property which holds the class's name. So that's just going to print the type of the model, like the class name of the model essentially. And we can see that with default parameters, random forest is performing really well. Now this 0.911 MAE can be interpreted as an average. At an average, the random forest predicts a value that has a maximum absolute deviation of 0.911 from the actual value. So it always predicts a grade that is within a range of 1. So is our train and test the split method good? Sadly, no, it's as bad as it can get. Think about a data set where you have something like 1, 2, 3, 4, 5, and what you did was you trained your model on 1, 2, and 3 and tried to predict the values for 4 and 5. This is absolutely wrong, because it doesn't have that much randomization. What we should do is we should train it first on 1, 2, 3, predict on 4, 5. We should train it on 2, 3, 4, predict on 5, 1. We should train it on 3, 4, 5, and predict on 2 and 1. Now this thing is called cross validation. You go through all of the possible permutations in your in your data set, and you try to train and test for all of the possible permutations. And you take an average of all of these separate permutations predictions. Now, you can definitely not do it for all possible permutations, but you can divide your data set in a few subsets, subgroups. So let's say you had 100 lines, you can divide it in a group of 10, 10, 10 lines. And then what you would do is you would train your model on the first 7 and then predict it on the 3 other. Then choose some other 7 and predict it on the rest of the 3. So this thing is called k-fold cross-validation. This is also available in Scikit-Learn under this sub-package. As a random forest regressor was performing the best, so let's try performing k-fold in order to see whether it is performing as good as it was without cross-validation. So these are all the these are essentially all of the scores that you're getting per iteration. We have defined folds in the k-fold as 10. So in the end, when we see the mean of it, we can see that random forest regressor is outperforming the rest of the model even after this cross-validation. So we are good to stick with the random forest. And now we can be sure that random forest is indeed doing the best job. There are again a few points that I would like the the participants to focus on. I have just explored the basics of regression-based accuracy testing. Nothing on the classification side. These are the topics that we should be exploring after it. Now we're pretty close to deploying our model, and the second to last step that there is hyperparameter tuning. Now, every model has some parameters associated with it, which control how the model actually behaves, because every model is actually just an equation. So let's say our model was something like this. Y equal to C0 plus C1x1 plus C2x2. Now, C2, C1, and C0, as many terms as we will include in this equation, it's going to change the way that this equation will work. So this is one of the hyperparameter for a basic linear equation. Now, now why hyperparameters and not parameters? Why are we calling it hyperparameter, not parameter? So parameters are coefficients to the variables that the model learns. So hyperparameters are constant throughout the life cycle of training. You cannot feed in your model more data in order to make the hyperparameters more accurate. And as we will dwell into the field of deep learning, we will see that that hyperparameter tuning is indeed the toughest job out of all. Maybe not the most essential one, but the toughest job definitely. So what all hyperparameters are there is the first question that strikes in our minds. And they vary vastly for every model that we have. Just think about all of the equations that you have seen till yet in your life, and every equation has its own set of constants that is used to modify how the equation works. And, two of the hyperparameters that we have for random forest regressor are n estimators and max depth. as the name suggests, random forest. And now what does forest have? Forest has a lot of trees. We explored something in the very first slide, which was a decision tree. So it's essentially just a randomized selection of decision trees. And that's all that random forest is. Now, one way of doing this hyperparameter tuning is the grid search. Let's try to implement it in Python. We'll again import our model. We'll get the model selection. From model selection, we'll get the grid search cross-validation. We'll define a mapping which says for the n estimators, all of the possible values in the search space that I want to provide are 10, 20, 50, and 100. Similarly, for max depth, I want to provide all of the values in search space that are 1, 2, 5, and 10. You instantiate your grid search cross-validation class with your model and these parameters that you want to search for. You fit your grid search CV on the training and testing data, and you'll get the best parameters. So this is going to take a little while in order to finish, because what it did was it just created all of the permutations for these things that we provided. So first it instantiated the model using 10, 1, then it instantiated the model using 10, 2, 10, 5, 10, 10, then using 20, 1, 20, 2, 20, 5, 20, 10. So that's why it created 16 instances of the model and found the best accuracy was using these parameters. So we'll be using these parameters in our final implementation. It might not always improve the accuracy, but if you do it right, it will always improve the accuracy. Hyperparameter tuning is something that is a little hard to get right. So let's implement it here. Again, we're doing the same thing. We're just providing a random forest regressor with the parameters that we learned from our grid search. Again, we are doing a k-fold in order to justify our accuracy. Let me just hit enter. Model is giving an accuracy of 84%. This is essentially the R-square score that we are getting for our model. And because we split the data of 300 data rows in 75 to 25, this is not really a bad accuracy at all. And you see that for some instances, you get accuracy as high as 93%. And for some instances, you get accuracy as bad as 75%. And that's the reason why k-fold validation, why the cross-validation is really important. So that's about all that we had for the 7 steps of machine learning. That's the 7th step, that is to make predictions. But there are many more steps in order to productionize model. You should explore how to save the models, how to define the Scikit-Learn modeling pipelines, and how to deploy models as a REST API to be consumed by the other applications. So coming to the closure of this session, I'll be discussing some of the problems with machine learning in industry, because I'm pretty sure that at least a minority that would be looking at this session must be feeling, okay, machine learning is all about just importing some libraries from somewhere in Python and just doing a .fit and .train. All that matters is I get some data from somewhere. And yeah, you're pretty much right about it if you're thinking that way. But The problem here is the amount of data that you have to deal with. It's really common in industry to deal with 100 and 200 gigs of data. I myself am working with a data of 120 gigs right now. So what Pandas does is that it loads all of the data at once in your RAM. You can ignore this for now. It's just added for the accuracy of this statement. So Pandas loads all of the data at once in RAM. Now think about it. If you have 120 gigs of data, then Pandas will consume at least 200 gigs of RAM. And I'm pretty sure that no one's computer has more than 32 gigs. So how do we actually handle it? So there are two ways of doing it. One is that you use some other cloud provider who actually can provide you terabytes of RAM. And the second one is, if you don't want to pay a cloud provider, you have some other options, which we'll explore here, just theoretically though. So how do you save and load such large amounts of data? Instead of using these comma separated files, which essentially has just text written over it, use some memory mapped storage formats. The one that I personally am using is HDF5, and the one that I'm exploring is Apache Arrow. I would highly encourage everyone to go through all of these formats. They're essentially referred to as big data serialization and deserialization formats. And as we will go in the deep learning, I'm very sure that you guys will come across HDF5 and protobufs. So, okay, I have saved the data and I can load it, but how do I process the data? That's the next question. For parallel processing, Python provides you something called Dask, which again works on parallel data frames. Again, you can see data frame is the catchword here as well. There is something called lazy parallel processing. So this is a little faster than parallel processing. So what lazy essentially means is that you only compute when you need something. So WAX has a concept of virtual columns, and it can speed up the exploration of your data. The third thing that is very common in all of this big data space nowadays is distributed processing. You can utilize PySpark in order to perform the same. There are other options available as well, but these three are the ones that I have mostly come across. And again, if you're not sure about the choices you're making, just stick with PySpark and you should be good to go. So just closing this session now. I guess I'm 4 minutes over my limit already. Apologies for that. So as the closing remarks, I'm pretty sure that no one can be expert in machine learning in a matter of a single session of 90 minutes. So some people must be thinking, oh, why do I actually use machine learning and where do I use it? I'm pretty sure that many people are thinking that there is deep learning, and that sounds cool. You can drive cars, create deep fakes, and do much more with it. And can machine learning do that? And apparently, deep learning is a subset of machine learning that deals with neural networks specifically. And with a lot of hidden layers in a neural network, it becomes a deep neural network. And we indeed evaluated one fundamental neural network if someone was paying attention, and I'm pretty sure that everyone was. And that was a multi-layer perceptron, which is the most basic neural network. So technically, yes, machine learning does all of it. But the conventional statistical ML models that we explored, just like KNN, random forest, linear regression, and all that, Those are associated with machine learning, and they are better suited for the jobs like predictive maintenance and all that. Also look at the problem that you are having at hand. This is a little funny statement. Try to read between the lines here. You don't need to use a nuclear bomb in a college fight. So if your problem is really small and you just need to do a house price prediction, it probably doesn't make sense to use a very highly convoluted deep neural network. So simpler the model, faster will be evaluation and faster will be solution to your problem. And with these remarks, that's all, folks. And give the report a star if you like the content. You can always contact me on these three endpoints if you have any questions, or if you would like to discuss anything. Thank you, RKGIT, and specifically Gaurav sir and Sachi madam for providing me this platform to open this wonderful FDP session that you guys have organized. It's a commendable effort from all of the RKGIT staff. And with these remarks, I would like to close this session. Hope you all enjoyed it and I didn't bore you all too much. Thanks a lot for the opportunity.
Thank you, sir. On behalf of Rajkumar Goyal Institute of Technology, the entire supporting team, our participants, and on my own behalf, I extend a very hearty vote of thanks to Mr. Ashish Shukla for delivering an informative and thought-provoking talk on basics of machine learning and hands-on with Python. It was really a splendid presentation which exposed our participants to the machine learning and automation that will generally thought could not be done manually. We are all inspired with your great words, sir. Our heartfelt thanks to great audiences as well for active participation. Thank you, sir. We will now continue the session, and I would like to introduce Mr. Amay Karkare, speaker for the topic Application of Machine Learning Techniques to Build an Intelligent Tutor for Introductory Programming. He is currently working as Associate Professor at IIT Kanpur. His area of research include compilers, data flow analysis, and heap analysis. He has been a part of various committees, including ISED, ACM Compute, CSE, Fluke, to name a few. He was also the coordinator for embedded system design for IoT for 2 consecutive years, 2017 and 2018 at IIT Kanpur. So without further delay, I would like to invite Mr. Amay Karkare to begin with today's session. Professor Amay Karkare.
Thank you very much. I suppose you can hear me?
Yes, sir.
Okay, so I will keep my video on for a few minutes just to show you the wonders of machine learning and other advances that we are having. So you all are using the Zoom meetings or other meeting platform, and you can see how wonderfully you can change your background without changing the person who is talking, right? So this is also one of the applications of machine learning, figuring out at what point my head or my body ends and the wall or background starts, and then changing it to a image or some virtual background. And how it helps us is that if some kid or some disturbance comes along, nobody notices. Okay, so thank you very much, RKGIT, for inviting me for this talk. And now I will share my screen. I will stop this video. So just give me a moment. So can you all see the presentation?
Yes, sir.
Okay, in the full screen mode, right?
Yes, sir.
All right. So today's talk is about building an intelligent tutor for introductory programming. And this is an application of machine learning techniques. So just before me, Ashish has described some of the techniques, and he has also summarized things very wonderfully, that before we apply a technique, we should also know whether it is really applicable or not. It does not help bringing nuclear bomb to a school for a fight, right? And so what I'm going to present is our experiences, things that we have used, and unfortunately due to time constraint, and again, it's not that I could not get more time. This is, I also have constraint. So I will be explaining these techniques. I will make sure that you get attracted towards how we are using it, but I'm not going to describe nitty-gritty details. So there are lots of practical things that you have to do, lots of engineering things that you have to do when you use a machine learning model. Those parts I will not describe. There are two reasons for it. One, as I said, is time. Other is that I am not a machine learning expert. As you heard in my profile, I am a compiler person. So I do research in the area of programming languages. So compilers, how you can make programs run faster. And recently my interest has been how we can help students learn programming better. So I am trying to improve how introductory programming courses are taught. So when you look at an introductory programming courses, where a student who is new to programming world is trying to learn programming, and now you want to analyze this and make it better, it's not just a machine learning problem. There are three angles. We need to understand something called program analysis, how to understand these programs which students are learning, which students are writing. We need to understand data science. Now, machine learning is a part of data science. So we have this data in terms of student programs. What inferences can be made from these programs, and how do we make use of them? And finally, as our goal in this case is improving teaching of introductory programming, we need what is called pedagogical research, which means which tells us what are the best practices that a teacher should follow and what are the things to avoid. Okay. And now there are three areas. I said I am only so-called expert in one area. So we need a lot of collaborators. So I just want to thank my collaborators in different areas. So we have a couple of students, Rajdeep, who was an MTech student. He built a very robust system which is being used, and you will see how this system is helping us very soon. I have Umer, who was my PhD student until last year. He graduated last year, and he did a lot of work in the intersection of program analysis and data science. So that's why I put him in the midpoint between program analysis and data science. I have collaborators from other places who work in program analysis area. So we have Sumit Gulwani, Jiang Hu, Shinvi, and Abhik Roy Chaudhary. In the area of data science, so we have Professor Arnav Eddarai, Purushottam Kar, and Renuka. And then finally, we have Professor Nishit, who is also a pedagogy expert at IIT Kanpur. And this project has been a cross-institute project. So we have Microsoft, IBM, Queensland University, Innopolis University, NUS, and apart from IIT Kanpur. So a lot of intra-domain, intra-university research. And in 1 hour, I have to explain all these things to you. So as I said, I am not going to go into nitty-gritty details. I will try to make you excited about the area, how you can apply machine learning to some problems which may not seem to be very conducive to machine learning. So why all this? So if you know that traditional classrooms are now changing into massive open online courses, where people are recording their lectures, putting material online, and hundreds and thousands of students are watching them. One of the challenges of teaching is providing personalized feedback. So if a student is facing difficulty in doing something, a good teacher has to give some feedback, how to solve this problem. Now in traditional classrooms, typically teachers go to individual student, ask their problems and can help them. And if this becomes time consuming, you can have multiple teachers or tutors or somewhere teaching assistants. So as you can see in this picture, there are 2 teachers who are helping girls solving some problems. Now the problem is when you go to massive open online courses, the first thing, teacher is now locked inside a box. Okay, so it's difficult to reach every student. But the other problem is the number of students. They are now no longer manageable. There are hundreds and thousands of students. So how do we give them personalized feedback? And when I talk about personalized feedback, what are the kind of expectations students have from teachers? So students expect that whenever they are stuck on some problem, teacher will help solve them that problem. And here again, I want to bring you a quotation of a well-known teacher, Joseph Albers. He said, good teaching is more of a giving of right questions than giving of right answers. So as a teacher, you will know that if a student is stuck and you just give them the solution, you show them the solution, the student does not learn much. Okay, so they get used to guidebooks and answers and so on, searching on Google, but they don't learn. To make them learn, you have to pose right questions so that they can figure out the answers themselves. So you have to do this step by step. And therefore, when we talk about expectations from a teacher, the expectation from a good teacher is that he or she should be able to give more problems of a given type to practice to students. So if a student is stuck, they should be able to practice and get used to those kind of problems. And there's another aspect. If a student is finding this problem really challenging, the teacher should be able to give slightly less challenging problem. Or if some students are finding these problems trivial, teacher should be able to give more challenging problems. So depending on the performance of the student, you should be able to adapt. So these are the expectations. But then being a good teacher will require you a lot of time. And as I said, with hundreds and thousands of students, time becomes critical. So it's not humanly possible to fulfill these expectations. And therefore, in a programming course, let's look at what are the kind of expectations. So when we are talking about large programming courses, and this is again typical course which is taught in every university in the first year, these kind of courses require manual help from tutors, because whenever a student is stuck with a program, they want some help in fixing minor errors. But what if the tutors are not available or the number is limited? Secondly, in case of these programming courses, you get lots of programs which students submit. And unless you are just using run-of-the-mill programs, it is difficult to analyze this program and visualize the kind of mistakes or the kind of approaches students are taking. Okay, so the common techniques to use is to use some kind of rule-based technique. So you use compilers to compile the program, see what kind of errors are getting in, and then run this program to see if the test cases are matching or not, and so on. And then there are some advanced techniques like program repair and others. Okay, the other kind of techniques which are now becoming popular are data-driven techniques, which we are going to discuss soon, some of those. And for this, again, to make it scale to thousands of students, we need to have what is called an intelligent tutoring system. So what is an intelligent tutoring system? So it is something which kind of adapts itself to student history, to student problems, and is able to give personalized kind of feedback. Okay, so if I just write down all the errors that students are making and then just post them on a website, that's not a good solution to help them, because a student might face only 1 or 2 out of 100 difficulties, and nobody likes to do extra work. So we need some kind of intelligence built into the system. So how can ITS help these expectations that I just described a few slides back? So ITS can help in generating solutions to given problems. And why this is useful? So once again, I can help someone with a problem only when I know how to solve that problem. So when I know how to solve the problem, then I can help students in completing their incorrect or incomplete steps. Or I can also give them partial hints. Rather than showing them the complete solution, I can use this to figure out where the student is stuck and tell him the next step. So this is like not giving him a spoon feeding, but giving him a small step to climb on. ITS can help in generating similar problem, and some of these things I will show you in the rest of the lecture. So given a problem, we want to find other problems which may not look like the current problem, but which have similar solution steps. Okay, so students should not be able to directly copy his or her solution, but they should be able to grasp the concepts. And similar problem generation is useful for demonstration when you do not want to solve the student problem, but show them the steps which are typically required, or it can also be used for giving them practice. And third one is parameterized problem generation. So given certain kind of input parameters or solution characteristic, we want to create problems that use those characteristics. So maybe in case of programming, we want to generate problems which use arrays, which use recursion, but which do not use pointers directly. So we will specify certain parameters and a problem should get generated. So these are useful for generating new assignment problems. And again, if you include difficulty as a parameter, and if you have some kind of measure of difficulty, then you can also generate adaptive questions with one with less or more difficulty. So what is our work in this area? So we have worked for last few years on what is called a novel multi-phase methodology for designing these intelligent tutoring systems for programming. We have developed some of the state-of-the-art ITS, intelligent tutoring systems. And in this road, we have collected lots of real user data, lots of data from real students who are doing these courses. And we have released this data for other researchers to use. So this is some kind of social service. And we are also using our techniques and we are doing user studies to measure the effectiveness of automated feedback. So it's very well to say that I am giving you the solution in certain way, but how do I know whether I am helping the student or not? Or maybe I'm just spoon feeding it in a different way. So we have to measure these things. So I kind of emphasize on this word multi-phased. The reason is that this multi-phase methodology has helped us in solving the challenge or conquering the challenge using divide and conquer method. We do not want to solve a big problem in one shot, but we are trying to solve small steps. But the other advantage is it allows us to plug and play different solutions, either developed by us or other groups. And finally, it also allows us to mix and match between different technologies or techniques. So as I said, there are two major ways of solving programming related problems, rule-based techniques or statistical techniques. So we are trying both ways to crack this problem of providing personalized feedback to students. So what is this multi-phase methodology? So let's take this problem of generating solution for a problem. We look at the original problem, we do some kind of abstraction. So we simplify, we remove things which are not useful, we simplify things which are useful properties of that problem. And then we abstract the original problem. We solve this abstract problem because it has a lot less features in some sense. And we use something called an offline computed data structure. So as you know, in machine learning, training is a very, very important phase. Now, if we are talking about machine learning based solution, this offline computed data structure is, let's say, training. But there are other methods which I may not describe in this talk, but in which we need some other kind of techniques to store what we learn from existing data. Finally, we have an abstract solution which may not be very useful to students. We want to show them what mistakes they made on their program. So we need a concrete solution. We need a concrete result. So we concretize it and present the concrete solution to the students. Again, whether to present it or not, it's a teacher's decision, but potentially our system can do that. The part that I have highlighted here. So this is the part which potentially can be developed using rule-based techniques or using machine learning-based techniques. As we will see some examples of using machine learning-based techniques soon. Similar problem generation also goes through kind of very similar process. We take the original problem, we abstract it, we solve it abstractly. Basically, we get some abstract representation, and then once again, we use these offline records to figure out a problem which is very similar to our current problem in abstract sense. And then this new problem, which in concrete terms look different from original problem, can be presented as a similar problem. And once again, the part which is now circled here or put in a line can be developed either using machine learning techniques, or it can be developed using rule-based techniques or any other technique which can take some existing data and produce results. For parameterized problem generation, things are kind of easy. You have certain parameters, you have to use these parameters to search for problems. Again, each problem has to be tagged with certain characteristics so that it allows it to search. So this is something very similar to Google search, but in some other domains. So once again, the part about searching the program can be done using machine learning or using some rules. So the question is, if we can do it in different ways, why should we use machine learning based techniques? And the answer is that, as Ashish also described, that once you have a data and once you have some patterns, it might be useful to take help of a computer to extract those patterns, because humans may not be very good at identifying these patterns. They are hidden. Okay, so we have sufficiently large data set. Again, take this with a pinch of salt. I'm not talking about a few terabytes of data, but I will describe what I mean by a sufficiently large data set. So if you look at a typical semester at IIT Kanpur, where first year students are doing their introductory programming courses, so we give them 12 assignments, 2 lab exams. So in all, for a typical semester, we gave them about 150 problems, 140 lab problems and 10 exam problems. And in return, we got 12,000, about 13,000 lab submissions and 2,700 exam submissions. So about 15,000 programs we get every semester at IIT Kanpur. Okay. Again, this 15,000 looks like a very small number when we are talking about machine learning techniques. But what is interesting is our internal system allows us to record intermediate versions of the programs. So typically each of these programs is recorded every 5 seconds, what students are doing. So what we get is about 50-60 versions of each program. So our database size suddenly increases by 50-fold. And now we are talking about 1 semester data. Okay. Why you might question why still use machine learning based techniques? The data is not that big. The idea is that students make same kind of mistakes over and over. This is our observation. If we look at students from the same batch, they repeat the mistakes of each other. And if you have taught any programming course, you will know that students forget to put semicolon, they forget to put closing brace and so on. And interestingly, every new batch repeats the mistakes of previous batches. So we see these patterns getting repeated again and again. And these are the kind of scenarios where machine learning works best. These are where machine learning works very nicely and quite faster than humans. Okay, so just an example, I am showing you top 3 errors and warnings that compilers produce in a typical semester. So students forget to declare their identifiers. So in case you have not taught any programming courses or you don't do programming, you may not appreciate it. But those who have done any programming courses will know that these kind of problems occur again and again, and students find them difficult to fix themselves. So about 122,000 instances of undeclared identifier in just 1 semester, around 49,000 occurrences of not returning a value from a function, and 48,000 occurrences of not able to write printf and scanf properly. So these data is specific to C program, because at IIT Kanpur we use C programming language. So we have total 11 semesters data with us, 12 semester is going on. But just one caution that not all of this data is released publicly. Some semesters data we have released publicly. Again, there are certain restrictions. We cannot release the data immediately after the semester is over. Okay, so that makes it around 10x more data with us. So now look at the kind of things that we have done. And our first paper in this area was called compilation error repair. So if a student is making error during compilation, how to fix it? And on the lines of democracy, there is a well-known quote on democracy. So we have called it compilation error repair for the student programs, from the student programs, because our system, we are not telling it what an error is and how to fix it. It is learning these errors and their fixes from student programs themselves. So this paper was published about 2 years back. So not a very old work, quite recent work. In fact, all the work that I'm going to present today is very, very recent. Okay, so what is a compiler error? So basically when you are typing a program and your program does not conform to the compiler's liking, okay, or programming language specification, compilers will throw an error. So let's look at this simple program on the left hand side. So here a student is trying to multiply a plus b with a minus b. However, because of our mathematical background, he doesn't know that a plus b followed by a minus b is not a multiplication in C language. You have to explicitly put this star. The right hand side shows what he probably intended. Okay, so when he wrote this program, a plus b applied to a minus b, as a teacher, you will tell the student, oh, you are missing a star between these two expressions, a plus b and a minus b. However, compilers follow certain rules. They are very strict. Hello.
Sir?
Hello, can you hear me?
Yes, sir. Yes, sir.
Okay, so I'll just share my screen in a minute. Okay, I'll just log in.
Okay, sir. Okay.
So is it visible now?
Yes, sir.
Okay, so I will continue now. Sorry for that. I think my system crashed, so I had to move to other system. All right. So things happen at the wrong time. So if you look at, so I was showing this example of a syntax error. Student writes something as if he is writing in a maths, but compiler or programming language does not like it. So the error message which is produced is called object type int is not a function. Now this is a very cryptic message. Okay, and if a student is trying to learn programming, the student will not know what does that mean. Okay. Another example of C program is very common mistake, people forgetting this AND character or ampersand character in scanf. So this is very, very common mistake. Again, if you look at compiler error, it says format specifies int star, but argument has type int. So quite cryptic error message. And again, student face lot of difficulty in figuring out what went wrong. And that makes them start hating the programming language course. And this is real experience. I have taught this course several times at several places. So why this issue? The issue is because compiler error messages are targeted towards experienced programmers. They are not written for students. So they assume that everyone understands these advanced concepts. And even if we try to fix them, it requires significant effort to make them informative. And then this effort has to be replicated for all programming languages, because if we fix C, we have to fix C++, then Python, then Java, and so on. Okay. And these messages are confusing as well as time consuming for beginners. And that is why beginners or students require help from teachers or teaching assistants. Okay. But then that is time consuming for teacher. So how do we solve this problem? So we solve this problem using our solution generation approach. And this is just a recap of what I showed earlier. So let's look at different steps and their specific use in our methodology. So how do we abstract the problem? Okay. So if you again do programming, you know that variable names are just for our use. I can call a variable X, I can call it count, I can call it array. For a compiler's point of view or programming language point of view, it does not matter. But what does that means is if you are trying to do machine learning on programs, somehow we have to be able to make sure all these programs are identified as one program, which only differ in variable names. So what we do is we do some kind of abstraction. We throw away variable name, replace them by types, because finally types are the important thing. Similarly, constant values also we replace by some names with types. And important things are keywords and operators like printf, if, then those are important things. We keep them as it is. So suppose a student has written some code like C equal to A times some unknown expression. Our later stages or our abstractor will convert it into a program like int equal to int unknown. Okay, so that later stages or our abstract solver has a easy job. Now comes the machine learning part. And once again, I want to emphasize this abstraction is very, very important, because we might have thousands of programs which might be representing just a single type of error. If we don't abstract it, we are unnecessarily loading our machine learning technology or any other technique with useless data. Okay, so it's better to show them something which is abstracted out. So what we are using in this case is what is called an RNN or recurrent neural networks. You looked at one kind of neural network in the earlier talk. So I'm not going to explain RNN very much to you. This is one kind of RNN which are very, very useful in translating one language to other. So the example image here shows that a German phrase H dicke kist can be translated automatically into English phrase awesome sauce. Okay, so what RNN do is it takes some input, it just takes us input sequence and it tries to compute the output sequence like yi here in this case, and yi will be computed from x1, x2, x3, xi minus 1. And then yi plus 1 will be computed using x1 all the way up to xi and so on. So it tries to look at a sequence of inputs and keep computing the next sequence in the output. There are lots of models and hyperparameters which are required to tune this RNN, but I'm not going to go into this. As I said, my main task is to make you interested in this area. You can look at Umair's thesis. I have given a URL here, but it is also available from my website. You can easily find it out. So once you have this kind of RNN, we have to train it, okay, to get anything useful out of it. So how do we do the training? For training, we are looking at real data. So what we take is 20,000 erroneous and repaired pairs obtained from 400 plus students who did our course. Now, as you remember, I told you that we only have about 15,000 programs which students submitted. So where did I get this 20,000 erroneous repaired pairs? This is because we are also storing intermediate versions of the program. So for a given student, we almost know how he started programming his code, what changes did he do to his program, at what point he compiled his program and found an error, and later point how he fixed that error. All this is kind of recorded, just like a video of his program. Okay, and we can manually inspect it, but it's much easier for a machine to inspect it. So from this data that we have, we looked at programs where version X had some compile time error and some later version X plus T did not have that compile time error. So we took these two programs and we kind of figured out which line was erroneous and how was it repaired later. So all this was done programmatically, and it gave us around 20,000 erroneous and repaired pairs. So where first component has an error, compile time error, second component has that error fixed. So we also used 4,000 plus test set. So we have training set of 20,000 programs, test set of 4,000 programs. So here is an example. Student wrote something. Again, he made the same mistake, missed out on that star operator, but later he realized that and he fixed it. Now note that not only he fixed the star, he also realized that these brackets are no longer required. So he removed the brackets. So we somehow extract these two lines, the error line and the repaired line, and use it for training. Now this training line where we have a student written program, we have to abstract it using the abstraction phase. And on this abstraction phase, we can use sequence to sequence prediction. So this is again a standard machine learning technique. And once again, this is also used for language translation. So what we are translating here is between an erroneous program and to a correct program. So when we just run the sequence to sequence prediction using our trained neural network, what we got was 3 different proposals, that these are the 3 fixes that a student can make. Now note that these 3 fixes, why did they come? So it looked like in many programs, student converted buggy code like this by putting a star in between and removing brackets. But in some other programs, so that program might be a solution to some other programming problem. We are not restricting ourselves to the current programming problem. We are looking across all the submissions, across all the batches, across all the semester, all the programming assignments. So maybe other people used plus operator, and some people did not decide to remove brackets, but they put a star. So depending on some parameters, our system just decided that these are the 3 best fixes for a given problem. Okay. Now one issue is that currently the fix is also in an abstract form. If I show this fix to a student, oh, you have made some mistake, you have to have int equal to int star int in your program, they are not going to understand it. Okay. So for that, to make it useful for student, we have to concretize the program or this abstract program. we use what is called map and store based technique. So when we are abstracting a program, we try to remember why did I introduce this int int here, because it was corresponding to variable a, or because it was corresponding to some variable count. So later we use this map to put back literals and identifiers of appropriate type. Okay. Another advantage of this is that the program that we get now is a program that can be compiled, which we can try with a compiler before showing it to the student. I mean, again, it will be very, very embarrassing if we tell a student that this is how you fix your program, and a student tries that fix and it crashes. Compiler does not accept it. So we do this sanity checking that the fix that we are going to propose is compilable. Okay. We use something called a cigar technique to concretize things. Again, not a very difficult thing. This is very similar to edit distance problem that many of you might have seen in your algorithm courses, where you try to convert one string to another using insert, edit, delete kind of unit operations. Okay, so we used the adlib tool, but one thing to remember is this is an approximate process, because a computer cannot guess what user intention is. It tries its best effort. Okay. So here is an example. Initially, we located the erroneous line. We abstracted it out into an abstract line. Then using our offline data structure or our sequence to sequence translation, we predicted that the fix should be int equal to int star int. And then we are trying to replace things. So as you can see, because this left side int came from a variable c, we are replacing it by c. The left side, the first int on the right hand side came from a variable a, we are replacing it by a. Star has to be introduced as told by our fixer. Okay, but this b is kind of a guess. So we look around this suspicious line. What are the other variables that exist, which the student has defined, or what are the other integer constants and things like that. Okay, so this b is a guesswork. It may or may not work, but the idea is that probably student will understand if we show him this running program. But this is where computer has solved it. Now the challenge is, now should we show this fix directly to the student? It might happen that it just fixes the program and students run it. Or should we show the student how others are fixing it? How other students made the same mistake, something which our computer has learned. And we want to impart that knowledge to the student rather than the fix. Or another approach would be, rather than trying to show him bad programs and their fixes, can we explain what error you made and how to fix it, maybe in Hindi or English or whatever the natural language student is comfortable with. So the example of this could be will be shown in the next lecture, but next slide. However, what I want to emphasize is these questions are not programming language related. They are not data science related. They are pedagogy research questions. What kind of feedback works best? So we are not going into that. What our solution is, we let the teacher decide. We tell them, okay, our intelligent tutoring system can give you these options. Now you select how do you want to show the student, show solutions to the student. And we are still working on these kind of techniques. So one way of showing the error is, so this is our kind of UI, part of UI. Student has made few mistakes. One way could be just show them the fix directly. Either change their code or insert these fixes as comments. Okay, this is the first part. We are showing fixes directly to the student. The second option would be to show that how others are fixing it. So basically we have to show an instance where another student has made same mistake and fixed it later. Okay, so this is like generating an instance of similar problem. We talked about it abstractly, and the second part of my talk will talk about it very soon. And the third thing, where we want to explain the reason in natural language, we need to convert our knowledge into natural language description. Now this is a very, very tough challenge, converting rules into English description or natural language description. So this is the future work which we are not yet ready with. Okay. So let's look at how to generate this example based feedback. So earlier I showed you that we have this fix, which we can directly show to the student, but maybe this is not the best way to help them. Maybe we want to show them, see some other student made similar errors and this is how they fixed it. So in this UI, I am just showing you the fix that other students have made, but ideally we have both the program line before the student has made the fix, so erroneous line, as well as the fixed line. So our UI is showing that for line 5, the expression you have written is not correct. Here is a similar expression which some other student has used to solve some other problem. So the idea is we are not spoon feeding the student. We are telling him to read, to understand something which is quite similar. If you look at line 8, we are showing that, see, this is how some other students have written printf line. So try to learn from it. And once again, if you recall that we have multiple fixes for a given erroneous line. So student can press this plus to get more and more examples. So in this case, for example, in second thing, line 7, student has pressed this plus once. So he got 2 examples, which are very similar to what line 7 is, but line 7 has some error. Here the line does not have any error. And similarly, student has pressed this plus twice in this case, so he got few more examples. So we can present more and more examples. Student has to go through these examples and try to understand. So similar problem generation, this was the flow, and let's look at different components. So we again have to do abstraction. We have to do computation, and finally we have to do concretization. So abstraction will come later. Let's look at our data set on which we are going to try this abstraction. So in this case, we used, again, similar data set, 15,000 plus erroneous and repaired code pairs. We could not use all in the previous case because there are certain difficulties or differences between the two problems. Okay. In this case, instead of trying to learn just the repair, we are also learning what is the error that compiler has reported. So for erroneous program, we are storing the error message that compiler has given. We are removing some program specific things like the name of the variable and so on, but the class of the error is remembered. And we are also trying to see what is the repair that student made himself. So in this case, student just introduced a star. So what we are saying, please add a star to the erroneous program to fix this program. Okay. Again, there are more details here, but as a very high level view, for if there is an error which was fixed subsequently, we remember what the error was and how it was fixed. And these two together are called a error repair class. Okay. So we use this error repair class. We label these classes manually. So there are about 15,000 pairs. We looked at unique input tokens. So we converted erroneous lines into what is called unigrams, basically a sequence of one token, bigram sequence of 2 tokens. And we also added the error message as I showed. So we tagged these lines and used these as our data set. What we found was there are 212 unique error repair classes. So basically where error message and corresponding repair are the same for the program. So we have total 212 classes. We ignored some classes which had very less number of items in them. So all these classes had more than 10 program pairs. This data set, as promised, has been released publicly for further research. People are using it. So this is just for information. So now we have to train our system. So this is the offline training phase. So we look at student code repository. We extract these erroneous code and corresponding repair code, this pair, and we have tagged it with error repair class manually. And we are now training our repair classifier. Okay. So we run our repair classifier, we look at the predicted class and we compare it, and feedback goes back for it to improve. The classifier itself goes through several steps. because it only sees these pair of programs. It has to figure out the line which has error. It has to do the code abstraction as done in earlier technique. It has to encode this information so that our machine learning technique can use it. In this case, we are using a different kind of neural network called dense neural network. And using dense neural network, we predict the class. Once we have the class, we know the repair, because remember, class has error ID as well as the repair that is required. So in training phase, error localization, it identifies the line where feedback is required. So again, there are a lot of state-of-the-art techniques to do that. You can look at the details in paper. This part is not that interesting. We can simply use compiler reported line. But in our studies, compiler reports correct error line only in 80 to 85% cases. In 15% of the cases, compiler reports a line which is different from where error was actually made. Code abstraction, very similar to our earlier thing. So I'm skipping on in this case. Okay. Now we have to do encoding. So let's say we got this abstract line int literal int equal to var int, and the compiler error message that was thrown by this line by compiler, we convert it into input vector called x. So remember that we had these 1756 different features, unigrams and bigrams and error things. So all this will be the ones which are present in the current line will be 1, others will be 0. So we go get a vector. There are some more details because sometimes the vector thing may not be of the same size and so on. So you have to align it. So those details are given in our paper or the thesis of Umair. Okay. Now this 1756 size vector is thrown into what is a dense neural network. Okay. In this case, our input layer consists of the 1756 inputs plus 1 bias input. These are our abstract tokens plus error messages. We have hidden layer, which has 512 units. Now, those who know a little bit about neural networks, it is very easy to overtrain it. Okay. So overfitting is a big problem. So to avoid overfitting, what we do is we throw away 20% of the knowledge at this level. Okay, so this is called dropout. So we kind of we try to ignore 20% of the knowledge, and then we predict the class out of those 212 classes that we have labeled or found out. So basically, now when we see an unseen program with some error, it will be converted into the input, and we will try to predict which error class it belongs to, and then corresponding repair will be sort of. But we also know that what are the student programs in our repository, which we had seen earlier, which have similar error. So we could use those programs as our examples. So just to show you the scores here. So when we used our data set with 3000 plus held out student program. So our 15,000 training programs are different. So we use 3000 other programs where student made some mistake, and we tried to predict which class this mistake belonged to. We saw that in 87% of the cases, our neural network is able to predict the correct class. And when I say correct, we are using a very strict notion of correctness. It means the fix or the error class that our system is telling is exactly same as what student did in that program, because we have the student full record of what he did later in that program. The correct class in top 3 in 98% of the cases, and in top 5 in 99% of the cases. So what it in some sense tells is that by clicking that plus or give me more example 3 times, student is going to get a good example probably 98% of the time. So which is a pretty decent result. Okay. Now in case of machine learning, just the precision is not very good. You also have to talk about recall. Okay. So in this case, we are having a recall score of 0.9 on more than 100 classes out of 212. So in 50% of the case, we are able to detect that a class or an error class perfectly. In 80% of the cases, we are almost 50% sure, more than 50% sure. However, again, note that this data depends a lot on training. When we try to train with very less number of examples, our recall score started going down badly. Okay, so that means that the data that we collected over the year is going to help us in building our, making our system much more robust. So about testing phase, as I said, whenever a live student submits an erroneous code, our error repair classifier will figure out the class. It will consult the student repository to suggest another program which has similar error and where the student had fixed it. So it will show the error as well as the fix. Excuse me. So here are some examples that we got from our data set. So this is the example we are using. So ignore the numbers. I mean, these are numbers that we gave internally. So this thing A plus B times A plus B, it was in some class, and the corresponding example that was shown to student or that was extracted was another expression where a multiplication operator is present. So in some sense, this is a relevant program. Here a student had made some mistake in using comparison operator. Now the interesting thing is the predicted class is not very good here. Okay, it may look like it is a totally different thing. However, the repair that is suggested is quite relevant. So we are showing him an example where another student has used not equal to correctly. Okay. Now fourth example is very, very interesting because here student has made a mistake in assignment. However, our predicted class has gone totally bad in this case. It is trying to convert this assignment into a comparison. Okay. In reality, the fix is that you have to have CH equal to CH plus character A. But that is not a very simple fix. It requires a lot of moving around of code and our system cannot predict it. So in this case, it is giving a wrong example, but that is expected because as you saw, our prediction accuracy is around 87% and then recall is also at most 0.9. Okay. So just to show you a summary of the results, when we ran so our training is all on single line of error. So we only take out one line which has error and then we take out the corresponding fix. Okay. So when we use this on 4,500 real life programs, we could match abstract solution 69% of the time. So now we are not talking about correctness of prediction. We are now talking about the correctness of the solution that we presented. Okay. And concrete solution that we show to the student that worked in 80% of the cases. So this is the first technique that I had shown. But if you use the same thing on multiple line errors, the program which has more than one errors present, in 44% of the cases, we are able to give proper repair to the student. Okay. So as you can see, when we are just showing them examples, we are pretty good. We are going around 98% in top 3. But when we are trying to show them exact fix, and if there are multiple errors in our program, then we are down to 44%. Now, this may sound like a very bad result, but the state of the art before our result was just 27%. I mean, you could only show repair, correct repair in 1/3 of the programs. And now we have about 69 to 80% of the programs which are getting good repairs. So the question is, we have now these two ways of giving repair or helping a student. How effective is this? To look at it, we did a user study. And as I said, this is so recent that I still haven't presented it. I will be presenting this study in July at a conference. So it's going to happen virtually once again. So this is something where we are looking at whether we are able to help students or not. Okay, so just few more slides and then we will be done. To do this study, we changed our user interface a little bit. Along with the program and the compilation error that we show to the student, we now show one of the two kinds of fixes. Okay, even though in this slide I am showing both on the left hand side, to a student we will either show the top thing or a bottom thing. So we divide our class into two sets. One set get a fix which is at the top, another set gets a fix which is at the bottom, and we are comparing the performance of these two sets of students. So we deployed it in our ESE 101 is our IIT Kanpur course for introductory programming, and we did it only for first half of the course. The reason is that we do not want to take it to very complex cases, because our tool is still improving itself. So we do not want to bias students with certain maybe possibly wrong results. So as I said earlier, lab is 3 hours long and student attempt 3 to 4 programming assignments. Earlier, the students were doing these assignments under guidance of TAs, but for a specific semester, we asked TAs to refrain from helping students. We kind of asked them not to help any student until some time has elapsed. Okay. So for that, during that time, student has to rely on this system called tutor or the hints that we are giving them. So TAs were not helping them. So this was done in second semester of year 17-18, around 2 years back. Half the semester, half the student got what we call a repair or the final solution, and other half got example. So the similar problems, okay, similar cases where other student had fixed similar issue. Okay, now these numbers are not balancing because we divided students based on roll number, odd and even. And some students drop the course in between. Some students kind of spoil the experiment by discussing things outside the class and so on, but they are nearly equal. And look at this, the number of errors are approximately half of other semesters, earlier semester, which we are using as baseline, where TAs were helping the students and we were not providing any feedback. So our system was not ready. So we have 3 kinds of feedbacks. First 2, where human TAs are helping students. Next, where we are showing students the final repair that our system generates. And the third one, where we are showing the student an example of similar error made by another student and how that student fixed it. Then we measured how much time it takes for the student to fix under these constraints. So in one of the semester, average time was 85 seconds, standard deviation was 137 seconds, 103 seconds in next semester, but around 75 and 78 seconds when we produce these automated fixes. Okay, now we have to again take this result with a little pinch of salt, because what we are measuring is the time when student got the error till the time he fixed it. Okay, now student may or may not ask the TA immediately. TA may have to walk to the student to help him. Okay, so all those times we could not refine. So the time taken by human TA are kind of over approximated. So we decided to do some more experiments. So we tried to look at what is called survival probability of errors. Okay, so what is the survival probability? So this is a very unique kind of a measure that we used. So we are using 3 different kind of help: repair, example, and manual. So here are the plots for 4 different semesters that I described earlier. So survival probability says that, let's say at time 0 you encounter an error. What happens after time 50 seconds? Is this error present or not in the student program? What happens after time 100 seconds? Is this error present in the student program or not? So we are trying to guess the probability of an error remaining in student program till certain duration. So as you can see, at time 0 probability is 1 because the error has just been made and I don't think any student can fix it immediately. But when we come to time 100 seconds, 25%, only 25% of the errors remain. Other 75% are fixed, and so on. So we try to keep labs and exams separate. There is a reason, because during exams, we had switched off our automated feedback system. We only looked at student performance without tutor help, without any automated feedback help. That is because during exams, tutors are also not supposed to help the students. So that's why during lab, we are giving them hints and students are fixing their errors. And you can see there is not much difference as such, but the time taken, the survival probability when you are looking at automated systems, it goes down rapidly compared to manual help. Okay. Now, when we come to exams, when all kind of hints are disabled, you see that survival probability is nearly zero, which means the difference between human and automated systems is not appreciable. It's very, very less. Now, is this a negative result? In one sense, yes. Our automated systems are not making students better programmers. Okay. But on the other hand, if you look closely, this is also a positive result because our automated systems are not making them worse programmer. Students are not dependent on the automated system to help them. They are not dependent on the tutors to help them. In both cases, whether humans help them or system help them, their performance is going to be the same. So what it tells us that slowly we can reduce number of TAs who are helping teachers, and we can use our automated system instead, which is much more scalable. See, our goal is to reduce dependence on humans. And if our system is performing as good or as bad as humans, then our system can be used. So let's look at few specific errors. So there was an error, E5. So basically EG10 is a group of error. Okay, in this case, there are two kinds of error. There's an extra comma at the end of a string. Okay, in this case, as you can see, we are only interested in repair and example. The student who got repair could fix their errors very quickly. The student who got another example, similar example, they were not able to fix it very quickly. As you can see here, repair feedback kind of gives them the solution. But example feedback shows them similar cases. Now student has to figure out where they have made the mistake and then go back and fix it. So as expected, the repair feedback performed very well. The survival probability is very, very low. Things got fixed very quickly. On the other hand, if you look at this another error, in which case a student has put comma by mistake. Okay. In this case, when repair was shown to the student, probably it was difficult for the students to find out what is the difference between code at line number 4 and code at the repair shown. I mean, for human eyes, semicolon and comma, they do not look very different. Sometimes we get confused between the two. So it took, probably it took some, this is our guess, this is our analysis. It took time for students to figure out what is the repair and fix it. On the other hand, when they looked at more than one examples, they were able to identify the difference easily, because in a way they are looking for a difference between the example that is shown with respect to the code that they have written. In case of repair, they are just trying to copy paste. Okay, so the error was fixed quickly with examples, but not with repairs. So this is the kind of study that we have done. And as I said, even though on the face of it, it shows that we are not something better than human TAs, but on the other hand, scaling humans is very, very difficult, but scaling a computer-based system is very, very easy. So to conclude my talk, I want to tell you that we have presented this multi-phase methodology, which allows us to use different kind of techniques, state-of-the-art techniques in fixing student errors while teaching them programming. The phases are abstraction, use of offline computed data structure, like neural networks in this case. We use some kind of abstract solver, not concrete programs. And then we finally concretize it before presenting them back to the student. It allows us to experiment with different kind of techniques. We have other papers which use rule-based techniques. So basically we tell if this is the error, you make this fix. Okay. Those are not presented here. They are not kind of aligned with the theme of the webinar. the workshop. Okay. And we have done some large scale user study which gave us insight into how ITS based feedbacks are helping users and what are the limitations, what is the quality of feedback compared to human TAs. Okay. However, currently we do not have sufficient evidence to say one type of feedback is better than the other. It depends on the difficulty of the problem. It depends on the understanding of the student and so on. So more studies are required, which we are planning to do in future. So basically we have to use, apply our technology to other domains beyond programming. So we currently were looking at only compile time error, but we are now looking at runtime errors as well. We are looking at totally different domains like trigonometry. In case of trigonometry, the steps differ. I mean, you can prove a trigonometric identity in many, many different ways. And all these ways are correct. So how to tell a student something which is close to his or her solution. And finally, we need some more user studies because as I said, there are certain factors that we could not control in our user studies. So we need a tightly controlled group and we need to involve other teachers because we need help from them about pedagogical aspects. So with this, I will stop my presentation. I just want to say that I have shared this slide with Professor Gaurav and I have put some relevant publication. Others are available from my website. And finally, I would like to acknowledge all the collaborators. My student Umair, who prepared the original slides for his defense, which I modified. And then I used several images in this presentation to make it more interesting. So I don't claim any copyrights for those. So I thank Google Image Search, which is embedded in Google Sheet. So thank you once again for all the audience and to all the professors and staff of RKGIT for inviting me for this very, very useful seminar.
Good afternoon, sir. This side Gaurav. Sir, you are having some questions in your chat box. Please have a look over that.
Right. So I can see, okay. So there is just one question I am able to see.
Sir, there are two questions.
In Zoom group chat or somewhere else?
Sir, Zoom chat, sir.
I don't know. Probably because see my system cracked and I moved here, so old questions may not be here. I'm unable to see them. I just see two questions from Dr. Sachi Gupta, but oh, okay. So I think she has posted several. Okay, okay. So sorry. So in this case, there is a question: what will be the research scope in deep learning? Can you state problem state for research? Okay, so even though my group has not used deep learning for our work, there is a group at IISc, Indian Institute of Science, who has used deep learning to solve the same problem, providing error repairs for students who are making mistakes. So you can look at that paper. They also used our data set. So once again, deep learning, it's a way of learning. Or it's a specific way of performing machine learning, right? So if you have a lot of data with you and you want to find some inferencing from it. In our case, the inferencing was given an erroneous program. How can I infer what will be the corresponding correct program? And the data we use was the repository of incorrect correct program pairs. Okay. So similarly, you can use deep learning for that. But one of the challenge with deep learning is why we did not use it is because deep learning requires more data. I mean, our data set is large, but it is not big. It is not huge. We still need probably 10x or 100x more data to train these deep learning networks. And the training time for these deep learning networks is also very, very high compared to our systems. So our systems could be trained in 2 to 3 hours. On the other hand, the other work I described from IISc, they are using techniques which require 2 to 3 days of training on regular CPUs and probably 7-8 hours on GPUs. Okay, So whenever you are using deep learning, remember that your computational requirement will be higher and they are more hungry for data. There is another work from IIT Kanpur by Professor Purushottam Kar, which is also published this year. He has in fact improved our system even further. For us, it was taking 1 or 2 hours to train the system. Now he has a system which can be trained in few minutes. So even so our modular approach has helped us in improving the performance of our systems as well. And I think Ashish said it earlier before my talk, and I want to repeat it. I cannot emphasize that, emphasize that fact, that please don't look at these fancy keywords. Don't jump into deep learning where regular rule-based learning can help you. Because rule-based learning will be much more efficient, much more faster, and you will have more confidence on it being correct. Machine learning, deep learning, you have to convince yourself that what you are predicting is correct, because it will be statistically correct. It will be 98% correct. It will be 99% correct. It can be 99.99% correct, but it will never be 100% correct. And most of the time it will require a lot of data. So I hope I have answered part of this question, and I cannot give you problem statements, and problem statements you have to find out from your own things. We can see the domains. I mean, biology, chemistry, mathematics, physics, all these domains are requiring machine learning. I think earlier one of your directors or somebody said that machine learning being used in agriculture, medicines, and so on. So I think those are the areas you have to look for. Okay. So thank you.
Thank you, sir. On behalf of Rajkumar Goyal Institute of Technology, the entire supporting team, our participants, and on my own behalf, I extend a very hearty vote of thanks to Professor Amey Karkare, IIT Kanpur, for gracing today's session and delivering his wisdom and knowledge on applications of machine learning techniques. I am finding it difficult getting the right words to express my gratitude to you, sir. The presentation really transformed the session into a highly productive one. A million sincere thanks to you, sir, for the sea of wisdom. Our heartfelt thanks to the great audiences as well for active participation. Thank you so much.
Thank you very much.
Thank you, sir. There's one announcement. Tomorrow's session will be from 11 a.m. and the link will be shared through mail.